Okay, we're going to get started. Thank you all for coming and for being here. We are super excited to kick off our CS Summit and our Capstone presentations for this year. My name is Chandra Krintz. I'm a professor of computer science, and I'm very excited to be leading this half of the Capstone projects. The Capstone is a class, it's a two-series class, and it lasts for 6 months. Professor Junwin Su taught the first half, the first 3 months. He then handed over the teams and the projects to me, and I oversaw and kind of helped the teams a bit, but it's really all been their doing in the last 6 months, seeing a project from nothing to go to complete fruition. Really exciting work. I'm so excited that you get to you're able to get a taste of it today with their presentations. This is our schedule for today. I'm just going to say a few words about really of thanks. The Capstone series has been super successful, primarily because of the collaboration that we have between industry and the university in order to put these projects together and these teams together. And so we work with the mentors of these different companies from industry. They present project ideas. Sometimes the ideas are completely the students. Sometimes the ideas are problems that the company is interested in pursuing. The teams then pick their mentors and decide what projects they're going to work on and who they're going to work with, and then they pursue this from specification to requirements generation to prototyping, implementation, and testing to what you will see today. We are assisted by a teaching assistant. His name is Mason Quarry. Mason, are you here? Where are you? He had a class earlier, so he's going to be a little late, but he's been wonderful. He's been with the teams from the beginning, and he has just been a vital part of our teaching staff. The companies that are our sponsors this year are listed here, and I just want to take a moment and give them all a huge round of applause for the participation. These companies are amazing. They've really benefited our students, and I hope our students have also, I hope they've enjoyed working with our students. But with that, I'd like to welcome up Leslie to tell us a little bit more about some opportunities for those of you who didn't participate this year to participate in the future.
You're all going to participate eventually. No escaping Capstone. First, I would like to have people recognize with a big, big applause Chandra. Chandra has been involved in this for, I think, 15 years or about there, and without her, this program would probably be smaller. So let's give her a round of applause. So I'm the Director of Corporate Business Development for engineering and the sciences, and we try to get these Capstone projects underwritten. A lot of you have heard, mostly from Chris Russo, who works for me. But if you don't find, by the end of this Capstone series of presentations, it's so compelling that you want to participate, then you're the wrong person. No, no, I would like for you, anybody that has not, as a company, funded and helped with these capstones. I am here all day. I have my card. I can write down your name, and if you want, we can get you started in Capstone as well. So thank you, and let's have a great kickoff.
Thank you, Leslie. Next, I want to send a big shout out to our judges. We have 3 judges. The goal of today is for them to understand the different projects, to meet with the teams, and to identify who is first, second, and third. And we will announce those after the coffee break. If you remember, our coffee break is going to be at 3:45. We'll announce the awards at 4:30 today. So we'll be busily working all afternoon to try to figure out who are our top 3 winners. Our judges this year are Davis Breimer. Davis is a serial entrepreneur who starts lasting companies. Davis has led physical and digital new product development and worldwide sales, support, community building for multiple endeavors. He has extensive experience across challenging domains, including medical diagnostics, stem cells, and life sciences. As a former professional DJ, radio talk host, and tech nerd, Davis has most recently returned to his roots to found a Web3 platform at the forefront of technology, entertainment, and gaming called Gamesodes. So keep an eye out for that. Davis holds a bachelor's degree in computer engineering and a minor equivalent from the technology and entrepreneurship from the UCSB. Next is Elizabeth Kate. Elizabeth is a proud UCSB Masters of Science ECE alum and currently leads the virtual healthcare strategy for Oracle Health from Santa Barbara. Elizabeth is a recognized expert with over 20 years of experience in technology, medical, and digital healthcare industries, providing a deep understanding and critical insights in the healthcare space. Elizabeth has held roles in research, product management, engineering, and program management for medical, telecommunications, and software industries. She holds patents in speech processing and digital signal processing. Prior to joining Oracle, Elizabeth held leadership positions at Amazon, Medtronic, Allergan, and Texas Instruments. She has also led an innovative digital healthcare startup and was the VP of Product and Development at Dictum Health. Elizabeth earned her BSCE from Rutgers University, an MS and ECE here at UCSB, and her MBA from the University of Laverne. Last but not least is Shelby Sailing. Shelby Sailing is a product manager at Logic Monitor here in town. Her team focuses on building out Logic Monitor's cloud monitoring offering, which is part of their unified observability platform that offers comprehensive visibility across infrastructure, networks, clouds, containers, and applications to enable intelligent automation and problem resolution for IT teams. Shelley's non-traditional career path spans sales, engineering, and product management, which gives her both a unique and well-rounded approach to modern SaaS, software as a service, product development. Shelley is a two-time graduate of UC Santa Barbara, most recently completing her master's in technology management from the College of Engineering. Thank you so much. These are our three judges up front. Can you just give them a round of applause as they do? Thank you so much for being here and taking part in this great event. And with that, we're going to have the Capstone team presentations. They are this order. If you have a program, you'll notice that 3 and 4 have been swapped, so don't think that's a mistake. This is the actual list. And we're going to start it off today with the team called Pina Colada. Their sponsor is Ag Monitor, and their title of their project is Smart Grid. Please, let's give them a round of applause and get them going.
Right. Hello, everyone. I'm Kaiwan. I'm joined by Alex, Jason, Jaden, and Yuan. We are sponsored by Ag Monitor. Today, we will be presenting Smart Grid. Have you experienced power shutdown before? The utility companies reports an average of 14 power shutdown events and over 1 million customers impacted per year. So to prevent a shutdown from affecting us, we can run an eco-friendly, self-sustaining grid in our home by implementing solar panels and battery. Due to resiliency and cost saving, the market share of the solar plus storage system is growing rapidly in the US. In 2019, only 4% of the solar systems are paired with a battery, but by 2025, we're expecting that to skyrocket to 25%.
So let's say you're convinced, and now you have solar and you have battery. That makes you a microgrid owner. Well, what's a microgrid? As you can see, it contains these 5 components. First, you have some form of renewable generation, like solar, and to have flexibility in when you use this energy, you need some capacity of storage, like a battery. Then we have your energy consumption, which we divide into your base and flexible loads. Base load is any non-negotiable usage, like lighting in a house. Compare this to a flexible load, which might be a Tesla, which you're willing to charge anytime within a flexible time window. And then finally, you have your utility to ground out your excess and deficit usage. Now, this is great, but how exactly would you manage this setup? This brings us to our 2 motivating questions. How should you set your battery threshold, and how should you schedule your flexible loads? Of course, when you decide to schedule these flexible loads has a direct impact on the overall microgrid system, and these decisions are further complicated by the considerations shown on the screen. But before we jump into the solution, one important concept to go over is the battery threshold, which is the minimum reserve energy you have at all times. A lower threshold gives you more energy to work with now, but puts you at risk during a shutoff. Compare this to a higher threshold, which gives you a larger reserve to weather a shutoff, but you might not have enough energy now, and you need to purchase energy from the utility. A solution released by Tesla takes advantage of this trade-off using the following human heuristic. It uses a 20% threshold in normal circumstances and increases that to 80% during risky weather. Now, this solution suffices, but it's a blunt solution, and a dynamic management tool could provide users better recommendations to take into account their unique setups and personal preferences.
So based on that thought, we come up with our twofold solution. For personalized energy management recommendations, we leverage machine learning to mathematically optimize the battery threshold and schedule for optimal energy usage. When designing our system, we favor an interpretable AI system over a black box model so that our users could be provided with justifications for their recommendations. Yet, users might also be interested in exploring their historical data. As you can see in the right picture, users can view their energy production and consumption data. So when we talk to our customers, they said they want to manage their microgrid quickly and on their phone. So from that, we design our action workflow, where we start with a scheduled AI computation, which runs on a daily basis to get the optimal battery threshold and best flexible load charging times. These recommendations are sent to users via text and email notifications, in which the users can then adjust their microgrid components accordingly here. And in addition to this core workflow, we have an extended one for monitoring purpose, indicated by these dashed lines, which gives users the ability to get more information about these recommendations. Furthermore, users can also explore their historical microgrid data ad hoc. So now I will turn it over to Jaden to demo this extended workflow.
So as the user, you will receive a daily email and text notification that is shown on the right. So more detailed explanations can be found on our website if you click on this link. So on the left of our homepage, you will see the recommended battery threshold. Clicking on this will show the factors impacting this recommendation, including your predicted net energy usage, your configured preferences, and any weather alerts. On the right, there are 2 recommendations. First, it shows whether to use your flexible loads or avoiding using it for the next day. Second, you will see the recommended best time intervals to start using energy. On this time bar, the darker the time slot is, the better to start using energy. Clicking on this will show an energy graph with your predicted solar and base loads for tomorrow. In addition to these explanations, you might want to explore your historical microgrid data as well. So on the Explore page, you can search for a specific date and view your energy usage data in both graphical and table form. So going back to the slides, I will talk about the system architecture. So we opted for a modularized architecture wrapped around in Docker containers to maintain a synchronized environment. And we also implemented a scheduler to run our AI optimization and send out daily notifications using Twilio.
So for the remainder of the presentation, I'll be talking about the AI portion of the project, and this is its general structure. Some background information. During our initial interview phase with potential users, we found that the greatest driving force was monetary cost, along with some consideration for things like avoiding shutoffs and being environmentally friendly. But in the end, different users had different preferences, which is why we decided to set up our cost function as a linear combination of these three major components with user-adjustable hyperparameters for customizability. Within the cost function, utility usage is a measurement of how much energy you're buying from the grid. Renewable waste is a measurement of how much excess solar energy is discarded by the system. And finally, power shutoff has to do with the level of risk for tomorrow and the amount of reserve energy you're maintaining. So by varying the threshold and schedule for this cost function, we're able to find an optimal solution that gives us our recommendations for tomorrow. And so with that objective in mind, here's a more in-depth graphic into our optimization process. In the center there, you see the minimization of the cost function as discussed on the previous slide. And when we were trying to estimate cost, we realized that we needed to be able to predict the battery behavior for tomorrow. And that's dependent on a number of components like the current battery level, along with the forecasted flexible load, base load, and solar generation. Unfortunately, we couldn't pull the battery level directly from a battery API because of privacy concerns. Instead, we're storing that value internally and using that for tomorrow's computation. On the bottom is a secondary flow where we're attempting to estimate the risk of a shutoff happening tomorrow. And the way we do that is by filtering out relevant weather alerts along with their severity. And so let's talk a little bit more about the predictions that we need. So when we were trying to predict flexible load and base load, we encountered a significant roadblock in that the historical meter data we got from the utility actually combined these two loads together. And in order to deconstruct this aggregate value, we had to utilize high and low pass filtering along with the historical solar data. So in the top graph, you can see the data inputs that we had access to, including the consumption, the excess solar as reported by the utility company, along with the actual solar generation as reported by the solar panel provider. And on the bottom graph is the result of the filtering process, where we've successfully identified the flexible load occurrence in green and also reconstructed the base load in blue. And once we've cleaned the data like this, we were able to generate insights like the average base load usage along with the average flexible load usage. And another key prediction we needed was the solar generation for tomorrow. And we opted to use an external API for this that gave us predictions based off of future weather data along with the solar panel configuration. And this gave us fairly accurate results, as you can see in the top right graph. But we saw a lot of room for improvement because we also had access to the historical solar data. And so by saving our predictions and comparing them to the actual solar generation, we were able to continuously compute weights that then allowed us to apply a transformation to this data in order to reduce systematic error. And so in the bottom right graph, you can see the end result after about a week of this rolling synchronization process. And we were able to see a significant increase in the R-squared score along with a decrease in the residual error. And so putting these components back together, this is the overall pipeline for our optimization process. And it's a lot, but we've shown you these components before. But just to recap, going from left to right, we have our key data inputs along with and then from these data inputs, we generate some predictions about the flexible load, the base load, along with solar generation. And based off of these predictions, we're able to minimize a cost function that gives us the optimal solution, and then from then we create our recommendations. And while we tested a lot of these components separately and individually, we also wanted to be able to verify the entire optimization process. So the way we did this was by generating recommendations for a week and then looking at a test user's actual energy usage. So in the graph there, you can see our test user's actual solar generation and energy usage for about 1 week with one occurrence of a flexible load usage. And on the bottom are smart grids recommendations. And not displayed here is the fact that those are our recommendations on the best times to charge but we also recommended that the threshold would be set to 20% every day, and also that they should be using their flexible load every day. So we found that when we shift the flexible load according to our recommendations, our user became about 98.5% self-sufficient on average. And that corresponded to about an 88% reduction in utility usage, which would have been a huge drop in their utility bill. So some final thoughts. Ultimately, home energy management is still a growing focus area, and there are many different ways of approaching the problem of optimizing the microgrid. We opted for a customer-centric solution, which is why we prioritize things like customizability, privacy, interpretable results, and simplicity. With that, we hope you use smart grid and save the planet and your wallet at the same time.
Questions from the judges or from the audience?
Great presentation, by the way, and a very timely project. So I had a quick question, and you may have touched on this. How would you handle disaster recovery in this scenario? I know you talked about weather events, but I didn't see that really explicitly described.
So you mean like in the event of a disaster, what happens?
Yeah.
Well, hopefully the system is able to warn the user ahead of time that a disastrous weather event is going to occur. So in that event, we would recommend higher thresholds, and we recommend not using your flexible loads. So you would have energy when a disaster does occur. And battery systems tend to be able to have a self-powered mode, so they would handle the actual operation during the case where the utility is offline.
And one thing I noticed in your app, and I'll say your first text message was very long. When you think about usability and the type of people that would use this, is there a way you could simplify it further, or did you think about that in terms of making it more automation, more predicted?
Yeah, so ideally we would have wanted to be able to adjust the threshold ourselves. So that would have been something that we could remove from the recommendation, but unfortunately we can't interact with the APIs because of security concerns. So instead we're sending that as a text message, part of the text message. But that could definitely be something that's removed.
And then this will be my last question. It's a highly regulated industry. Did you think about compliance standards, security, encryption, and how that may impact the performance of the system?
Yeah, so that's definitely a concern we had, which is why we decided not to interact with some APIs, because there's simply too much information or too much control that we would have had access to. So that's definitely a big concern, and so we sort of avoided that issue by just not interacting with that and building around it.
I have a question about your broader business model. Do you see this as a standalone third-party product, or do you see this as taking this to companies and integrating with an existing solar company?
Yeah, so I think this product is definitely a standalone product, definitely, and I think partnering with Ag Monitor is really good, because then we can we have this product and we can work with Ag Monitor to further develop it, or if they want it, then we can give it to them as well. And it leaves it very open-ended, but yeah, I guess it can go both ways.
Okay, with that, we'll bring it to a close. Thank you so much for your questions. Thanks for being again. Our next team is called Segfault, and their project is called vCare, and they're working with the company Well Health. Take them just a couple minutes to get set up, so just relax for a second, and then we'll kick it off with the next talk. He'll turn it on. I'll do it. Test, test, test. It's working now.
Excuse me, yourself.
Sorry, thank you.
What the fuck? Yeah, you might use this or carry this around. My laptop here.
Yeah, let me hold it. Hello? Yep. Just put that in for me. Cool, we're good. Okay. Hi guys, we're Segfault, and our project is called vCare Virtual Reality Therapy. Let's hit the slide. So this is Segfault. My name's Neil.
I'm Kevin.
I'm Tom.
I'm Easton. I'm Yusong.
And I'm going to let Kevin tell you a little bit more about our project vCare.
From 2019 to 2021, there's a 400% increase in adults reporting anxiety disorder, from 10% in 2019 to 40% in 2021. Anxiety and stress disorders can affect every part of an individual's life, from unstable moods to increased heart rates. One of the methods in combating anxiety disorders is exposure therapy. Exposure therapy essentially exposes the patient to less stressful versions of their anxiety source, allowing them to be more accustomed whenever they do encounter it in their daily lives. 60 through 90% of patients report either no symptoms or very mild symptoms upon completing their exposure course therapy. Also due to the pandemic, many people that are already in mental health therapy were forced to turn to virtual options. vCare makes exposure therapy accessible virtually, whereas previously it was only possible in person. A specific case we wanted to target was social anxiety. As people are returning to everyday life following the pandemic, many people are finding it difficult to adjust to the post-quarantine world.
So vCare aimed to make the exposure therapy more accessible through three main components. The first one is the VR environment. We create a controlled virtual environment where patient can be exposed to the source of anxiety. In our social anxiety case, the source of anxiety are presented in ambient noise and also the number of people in the room. The second main component of our project is a real-time feedback loop. We use sentiment analysis, tone recognition, and also emotion detection to measure the stress level of the patient, and also adjust the intensity of the psychological stress. Depending on the analysis of the patient's stress level, vCare will automatically adjust the intensity of the level of noise and also the number of people in the scene throughout the entire exposure therapy. The third main component of our project is the live transcription and post-session analysis. Simple graphic will be generated based on the session data after the exposure therapy. This will help the patients to see their progress through over the course of the exposure therapy. This will also help the doctor to see the overall performance of the patient and also adjust the future treatment accordingly. And now let's jump into the demo and see what it is.
Okay, so now we're going to begin the live demo. We're going to be having Easton here with the VR headset VR patient, and we're going to have Neil be the therapist. So right now, Neil is logging into his therapist screen, and now he's going to be pressing setup, which will begin the entire demo session. Okay, and now we can dive Easton into the VR world. Okay, so hopefully now you guys can see everything that our patient is seeing right now. He is clearly in the virtual reality world now. Easton, I'd like you to press the begin demo button in front of you. Okay, so now Easton is being taken to a video conference room where he can have a little one-on-one chat with his therapist right here. This is for just basic introduction. So now Easton, I would like you to press set up.
Hi, Easton. I hear you're having some trouble with social anxiety. So don't worry, we got you covered. We're going to put you through a little bit of an exposure therapy session, but don't worry, the environment is entirely under control. The system will try to adjust to your level of comfort, and I am able to step in anytime we need to. So if you're ready to get started, go ahead and press the Begin Simulation button in the top corner right there.
Yeah, I'm ready. Okay, so upon pressing Begin Simulation, he's taken to a restaurant which we set up for the purposes of handling social anxiety. In this environment, there are two stressors being applied to the environment, that being the number of people in the environment and the level of ambient noise in the environment. These two stressors work together to give the environment a level ranging from 0 to 10. So the therapist here can show us what level 0 looks like. Okay, so at level 0, no stressors are being applied, no ambient noise, no people. Now, let's show everyone what 10 is like. Okay, so 10, maximum amount of people, maximum amount of ambient noise. So we're gonna bring it back down to 5 now, right in the middle. Okay, so the basic idea is the environment will adapt to the patient's physiological state and try to see where his mental threshold is in regards to social anxiety. So both the therapist or the system can manage this level of stress. So we're gonna have Easton say a couple things here.
Oh, I'm so nervous. There are still so many people here. I'm just anxious. I hate this place. I want to get off this place.
Okay, so let's take a little bit more of a look on what Neil's seeing. So if you look down here on that control panel control panel right there, this is where Neil is able to manually control the stressors of the environment. Up here, you can see a view of the patient in the VR world. Right over here is a transcript, a live transcript of whatever the patient is saying. Up here in this area right here, everything that is flagged as negative in that transcript will be shown up here. So now we can go back to the VR world. Okay, so as long as Easton here, the patient, doesn't show any sort of adverse negative emotion, the system will try to automatically raise the level of stress and push Easton, the patient here, into higher levels of stress. For demonstration purposes, the automatic level adjustment, the interval, is very short, just to let you guys be able to see it a little better. So we're gonna let that run for a while.
We're on level 8 now. So we're good.
I feel much better right now. I love this place. Thank you, Neil. I love this session. It makes me feel comfortable. Right
Okay, so we can, let's end the session and let's see what happens post-session. Okay, so here is just a brief list of like previous sessions that the therapist may have had with other people. So we're just gonna press on view session details on the most recent session, which is the one we just had right now. Okay, so here you guys can see a couple of post-analytics data. If you look at the graph right here, this is a circle graph of the time per level that the patient has spent per level, and this is useful for seeing at what level is the patient least comfortable at, and at what level are they most comfortable at. Right next to that graph over here is a sentiment distribution chart, which just gives you a better idea of positivity, negativity throughout the entire session. Below that, you'll see a timeline of the levels throughout the session. Right here, we started at 0, we climbed up, we dropped it a bit, and we let the automatic level adjustment go up for a while throughout the demo. This chart is useful for essentially testing Easton's upper mental threshold for this session, and over the course of multiple sessions, we can see Easton progress in that upper mental threshold as he is able to withstand higher and higher levels of stress. Below that, you'll see a little bar graph of emotions over sessions. This is just a simplified graph of just the certain levels of, or the sorts of emotions that he felt throughout the session. And last but not least, below that, we have a session transcript of the entire demo, which is everything he said over the course of the entire session. It is saved, it is sent to the therapist, and he can analyze that after the session maybe do other things with it. And that ends the demo. So now I'll be handing it over to Neil to talk about the architecture.
Hey guys, so I'm going to talk to you guys a bit about the architecture behind what we just saw there. So, in essence, the entire system is designed with this whole feedback loop that we keep mentioning in mind. And we wanted the system to be able to automatically adjust to the stress level of the patient. So our architecture looks a lot like a loop. The loop starts at the bottom right, yes, or bottom left for you guys, sorry, bottom left with the devices. This is where the patient interacts with the system. This includes the Oculus and the patient's computer. Now these devices capture the audio data of the session as the patient talks to the therapist and sends this audio data to the brain of our system, which you can see in the upper left, MarsView. MarsView is a very neat API we found, and they do a lot of analysis on the audio, including sentiment analysis, tone analysis, emotion detection, and they spit out a bunch of metrics for us, which we feed into our Firebase real-time database, which you can see in the middle of the screen. Firebase real-time database allows us to make these metrics available in real time to all parts of the system as they happen. So as this patient is speaking, we have access to the analysis of what the patient is saying immediately. Now, we have the other part of our system, which is the Django server. This is the part that the therapist interacts with. Now, the Django server will take the metrics from the real-time database as they become available and aggregate them. And store them in our persistent database, MongoDB, signified by the green leaf. And what this allows us to do is analyze the patient's mood over the course of a significant amount of time. So if a patient spends more than just 10 seconds in the case of the demo, or 2 minutes in the case of an actual deployment, if a patient spends, say, 10 minutes on a single level, when the system determines whether we need to change that level, it is taking into consideration all 10 minutes of analysis of while the patient was on that level. Once the system determines whether the level needs to change, it sends that data back to the devices, so the devices can then adjust to the comfort level of the patient. And that concludes the feedback loop and allows us to adjust the environment in real time to the patient's mood.
So we have been through a long way to set up the environment and implement the key functionalities for our project. But there are more features we can realize in the future. We want to add more parameters to our automatic adjustment algorithms. For example, the heart rate through an Apple Watch could be a valuable data point for insights to a patient's mental state. We want to make the virtual environment more interactable with scripted conversations or game objectives. We can also add more environments into our system to combat other disorders, such as fear of height. Translation. An excellent therapist could benefit patients all over the world. By launching the real-time translation, the language barrier would no longer be an issue to be worried about. We will continue developing, optimizing, and maintaining our project to make the whole virtual therapy session more organized and convenient. Thank you very much for joining our presentation, and we are ready for any concerns and questions.
Questions?
Great, thank you. Great presentation and really interesting project. 2 questions for you. One is the VR headsets, the hardware right now are somewhat limited in terms of accessibility. So I'm curious how you guys would consider, would this be limited to only consumers that have VR headsets, or might VR headsets be provided as part of the session?
So the VR headset at this current time is essential to the session, yes. And the hope would be that, A, it's immediately accessible to patients who already have one. B, we would hope that perhaps the practices that are offering this therapy might provide VR headsets for their patients as a sort of added benefit that put them ahead of other practices, maybe competition. We also heard potentially from our Well Health mentors that maybe insurance would cover it for some patients. So we are aware of the accessibility problem with VR hardware, but VR is such an exciting technology that I don't think it's worth waiting for it to become widely accessible before we start exploring it. And I guess that's the motivation for the project.
Thank you. And then second quick question is, What other environmental parameters, if you guys were to expand beyond ambient noise and number of people in the room, did you consider others, and if so, what would they be?
Other parameters to adjust? Yes, so we wanted to have scripted conversations that the patient could undergo with these non-player characters to really drive home the fact that you're in a social setting. And one of the parameters that we discussed was adjusting the intensity of that conversation. So you could have a random character come up to the patient and ask them how their day is going. Or you could have a random character come to the patient and start yelling at them for no reason, right? And the intensity of these interactions, I think, is a really important part of the social anxiety problem, rather than just being around people, interacting with people. But unfortunately, we didn't have enough time to implement that, that feature as a part of this demo.
I had one question about the sentiments. You may have covered this, so apologies if you did. Was the sentiments, I think you had different classifications of emotion. Were those determined by was it determined by your solution, or was it input manually from the therapist?
It was determined automatically, yes. We send the audio data of the session to MarsView through their API, and they spit out the analytics. Yeah.
Thank you.
I grilled these guys earlier, so I'll just ask you one question. It's in your roadmap, that's really great that you're looking at other physiological inputs like blood pressure and heart rate. But what about things like social determinants? One of the things that can happen when you're in a remote situation, and especially with mental health, is their environment, social determinants around age, food deserts, food insecurity, things like that can add to their stress. Have you thought about how that could feed into your system and what that might look like?
Sorry, can you repeat the question?
Yeah, it's really about adding things beyond the physiological, but social determinants that some things like demographics of a patient, where they live, are they in a food insecure environment? Because those are the kind of things that will add that level of stress, or even looking at, the type of things that is it for PTSD and that sort of thing, like what sort of environment triggered that, and can you tailor that, or did you look at that as adding a parameter?
No, actually, we didn't, but that is a very interesting idea, and I will now be thinking about it for the rest of the week. Yeah, sorry.
Thank you so much for those great questions. With that, let's thank our team one more time.
Thank you.
Next up is a team. Their name is the Exceptional Null Pointers. And today they're going to talk to us about fighting the UCSB housing crisis with Realm. They're working with AppFolio.
Hello everyone, we hope you're having a great day so far. We are here to introduce you to Realm, the real estate application and listing manager. I'm Kobe here with the team, Wade, Kevin, Noah, and Eric. Our sponsors, AppFolio, and our mentors right in the middle here are Justin Pearson, David Shen, and Chev Eldred. So, housing is a task we've all had to approach at one point of our lives, or eventually will. So let's look at some common statistics about the real estate market. The first one being 93% of home buyers use websites to buy their homes. This is important because we're in the CS Summit and technology is a growing field very rapidly. The second slide we should look at is that annually 44.2 million people rent out their homes and a staggering 100.9 million people live in rental housing, meaning if there's a problem in the process of acquiring housing, then it affects a large group of people very rapidly. And the last one that should really hit close to home, around 29.4% of UCSB students in a self-survey indicated that they had no confirmed housing for the 2021 to 2022 school year. So what's the problem we're trying to solve? Essentially, there's a housing crisis in Isla Vista, Galeta, and Santa Barbara, and this is made no easier by the fact that searching for housing is a confusing, tedious, and inefficient process. It's confusing because there's so many websites to start at, you don't really know which one to choose. It's tedious because Because once you find these multiple websites and listings you do like, how do you keep track of them? You have to make multiple accounts, keep open tabs, write it on a notepad, etc. And it's inefficient because partially keeping track of them is a pain, but also there's no real built-in way to share them with other people you want to get their opinions on, such as family or friends. There are current solutions out there like Zillow and apartments.com who do have good functionality, such as a map so you can see local listings, and they do have name recognition. They're probably one of the first websites you do go to. However, they do have some flaws that we hopefully try to solve, such as none of these websites individually have all the listings available on the market, meaning each one of them only has a partial view, so you have to visit all of them if you want the full view. And none of them really have a good way, a clean built-in way to share listings with roommates, family, friends, potential roommates, anyone you want to get their opinions on.
So our solution to this problem is to create a web application which aggregates rental listing information using data from both Zillow and apartments.com and allows the user to conveniently view this information with both search and filtering options, reducing the need to go back and forth between many different websites, and overall just making the process of finding housing much less tedious. Users are also able to save and share listings with their roommates through the app, making communication with roommates much more efficient. They're also able to view recommended listings so that they can more easily find properties that they may like and making the process of finding housing much less confusing. So what makes us different from our competitors is first in the aggregation of data that we do. So again, we use data from both Zillow and apartments.com to show available listings, which is something that neither of them have, right? They only have their own sets of data, but we show both. This makes finding housing through our app overall much easier as compared to our competitors in this way. Second is in the social features of our app. So Zillow and apartments.com both have ways of viewing and saving listings, but from the renter's perspective, it pretty much stops there. So we add social features to our app which make it easy to communicate, which make it easy for roommates to communicate and share listings with each other. And you can see on this next slide in one way in which this manifests is in the bookmark page of our app. So on the left, you can see your like listings, and on the right, you can see your roommates' like listings. So instead of having to text back and forth with your roommates saying, what do you think of this? What do you think of that? You can just see all that information right on this page. On the bottom, you can see the recommended listings. So our recommendation engine uses both your like listings and your roommates' like listings to calculate similar properties to the ones that you've liked to show you things that we would recommend. This, just overall makes the process of finding housing much easier because we do a lot of the work for you. Now, Zillow has something similar to this, although it's not completely obvious that it's on their website, and we couldn't find anything like this on apartments.com. Something else to keep in mind as well is that, unlike these other companies, we don't have a profit motive, so you can be sure that whatever we're recommending here is not being pushed there because someone paid us to do it. So now we're going to go to a live demo, and you can see here that we start on the landing page of our website. You see a very nice picture of Santa Barbara, and we're ready to find housing. So first we're going to go to the roommates tab so that we can create a roommate group and find housing together. You see that the rest of my team has actually already been in a roommate group, and I want to join it so that I can find housing with them. You just can put my email at the top, press invite, and you see that I was successfully invited to the group, and I just got an email actually on my phone that said I was, and I'll click that email later and join, but first my team can go ahead and find housing.
Yeah, so now that we're all in a roommate group together, I can kind of demonstrate the flow of what looking for a house or a place to live will look like. As you see, we're back on our landing page, and we have a drop-down to select locations. We can just click search on Galeta, for example. After a second, it will load, and a new page will pop up, where on the left side, there's a table of all the listings, and on the right side, there are corresponding icons on a Google map. If we decide for any reason we want to change to Santa Barbara listings, we can using the same drop-down on the top. We can research, and Santa Barbara listings will now show up. If we have an idea of a type of property in mind, we can use the filters up top. And let's say we do want a place that allows cats, so we can select a yes for cats. If we want a place that has 2, 3, or 4 bedrooms, we can input those options as well. And a group of us, we have a minimum budget of $2,000. Anything not put in will have a default value. Now, once we click apply filters, we see that the number of listings on the table on the left and the corresponding icons on the right do minimize in number because these are the listings that strictly adhere to the filters we set. We can even sort using specific attributes if we want to as well. We can sort by rent price to see the most expensive or the cheapest listings first. And if we want to get really nitpicky with it, we can type in keywords into the search bar that will hopefully show up in the descriptions, such as furnished. After all this, we see there are a couple properties on the table, and we can even open the descriptions to see the descriptions and the keywords that we looked for. As you see, if you hover over the listings too, the corresponding icon on the map highlights as well and doubles in size, so it's really easy for the user to indicate where it is, and it's user-friendly. Once we click the icon too, there's a modal of information that does pop up for even more detail, and we can click the link for its own unique page.
So after I click on a specific listing, we will be able to land on this dynamic page. All the basic information about the property will be shown on the left side. There is also a gallery of cool photos about the property shown in carousel style in the corner. And finally, its own and unique position is indicated on the Google map. So at this point, if I'm very satisfied with the property, what I can do is to click on this like button to save the listing information into the bookmark page for later reference. Or if I need more advice or opinions from my roommates, I can click on this share button to share the listing information with all my roommates via text or email to notify them.
So now that we found a property that we're potentially interested in, let's go and check out the bookmark page. And as you can see on the left-hand side, you can see all of the all the properties that I've personally liked. And if you look closely, you can actually see the property we just liked. And on the right-hand side, you can see all of the properties that my roommates have liked. So this helps coordinate the process in finding what everyone is interested in. And what Noah alluded to earlier is our recommender engine, and this is where it actually lives. As you can see, we now have recommended listings based on what I've liked and what my roommates have liked. So now that we've gotten a taste of how the app works, let's go talk a little bit about how it's actually implemented. So we are a traditional web-based app with the industry-grade tech stack, but the more interesting part is actually in our aggregation of data in our recommender engine. So AppFolio has provided us with live Zillow and apartments.com listings, but the problem is that is way too much data for our app to handle at once. So we actually have to use AWS to filter through these listings and return Santa Barbara-based properties and put it into a cache that we can access through an API. Secondly, our recommender engine is also in AWS. This allows us to use the cutting-edge Python, AI, and machine learning libraries, and it also allows us to make different versions of our recommender engine and deploy it easily without actually making any source code changes in our app. And so as you can see, our architecture is unique, it's industry grade, it's scalable, and it's privacy minded. We actually do care about your data and we don't pass it around. So let's talk a little bit more about the advantages in our architecture. I talked a little bit about the recommendation engine, so let's talk about it a little more. It's our plugin recommendation engine. So what does that actually mean? The first version of our recommendation engine was built internally by our team, and that's what you saw working and demoed today. The second version has actually been a collaborative effort with the UCSB AppFolio Data Science Capstone team. So they've actually built us a recommender engine, and we're actively working on implementing that into AWS. Once that's fully in, it'll be a matter of minutes until our app is actually using that recommender engine. Secondly, I've talked a lot about Zillow and apartments.com, but the story doesn't end there. Our architecture is set up so that we can actually add more listing feeds, such as Zumper or RentPath. And lastly, we've built our architecture with the idea of potentially open sourcing our app so that we can actually get the community involved in the development as well.
As we mentioned before, we distinguish from other rental listing websites because we collect real-world feedback from the users every single week. And accordingly, we iterate on them and polish our app. We collect the feedback from the users from the following ways: Reddit posts, UCSB undergraduate email blasts, feedback form embedded in the app, one-on-one interviews with the users, and finally, AppFolio senior UX designers. We are very happy to say that we are able to use what we learn in class to help those around us in real life. Our app is currently being known and used by the public. We have 147 active users right now, and this number will continue to increase. Here's some feedback summary from the users. According to the survey, around 90% of the users said they would love to use the app. For some positive feedback, the listing display and filtering option is very intuitive. It is very convenient to group all my roommates. And finally, I can find what I want through the recommendation engine. For some constructive criticism, I hope we can have some rating system so that we can filter based on the rating of the property. It is really hard to find roommates if we do not have a roommate group. And finally, the formatting right now is a little bit cramped.
So now that we've gotten all this user feedback, what have we actually done with it? Well, we've gone ahead and integrated that into our Agile workflow. And on the screen here, you can see the first iteration of our listings page in a card-based format. Then we got some user feedback that it's really hard to tell where these are in the city, so we went ahead and added a Google map. Then we got even more feedback that this card-based format on the left is a little clunky to go through. So we went ahead and added a table format. But yet, we still had the problem of users were saying it's still hard to search through these properties and filter and see where it is on the map. So we went ahead and added filtering at the top and the ability to highlight a listing on the Google map based on the table property. And so another example of this is actually in the bookmarked page, which had a similar style format with the card formatting. Users then reported that they wanted to be shown in a more compact way, so we went ahead and did that. But then they also said they'd like to see what their roommates have liked in addition to what they've liked, so guess what? We did that as well. And lastly, we got more feedback that the users wanted to have recommended listings to help ease in the process of actually finding housing and take some of the burden off themselves. So we added the recommender engine as here. So in both examples, you can see 4 different iterations our app has gone through, and each time we've incorporated user feedback. User feedback has been crucial in our project because this app is based for the community. And so while our app is being publicly used and is great right now, we think we can make it even better in the future. Currently, we're a web-based app, so we'd love to be able to add mobile functionality. Secondly, we'd like to implement a common application form so that users can actually apply to listings through our property, through our app. Secondly, we'd like to be able to directly message property managers through our app so the whole roommate group can get involved in this process. And lastly, we'd like to create a page to find new roommate groups, or new roommates. Sorry about that. So we'd just like to thank everyone for listening, and especially our mentors, Justin, David, and Chev. This honestly would not have been possible without them. We'd like to thank Professor Krintz, Sue, and Mason these past 2 quarters, and everyone here for listening. And like I mentioned, our app is live and on the internet, so you can feel free to navigate to this link and play around with our app during the other Capstone presentations. Thank you.
Questions from the audience?
Great presentation, guys. Did AppFolio buy you out yet? Just kidding. So I'm curious, how might you consider, or could you consider, integrating a lot messier data, for example, like Craigslist?
So that's an interesting question that we've been kind of thinking about how we'd solve that. Basically, we'd have to first scrape that data, but we'd have to ensure that it's kind of clean data, and that's a really difficult process. And we actually run into that problem a little bit right now because some property managers don't update their listings as often. So the long story short is that's a difficult problem that we'd have to think more about on how to solve and do it in a really good way such that users actually would want to use our app still.
Great presentation. I love the fact that you got customer feedback. That's great. And I'm going to ask a question I think I asked you guys earlier about, can you add more automation up front? Do you think about that so that it knows much more about the person that's looking at this? So not the filters, but the automation piece of it. And how would that look in your flow, in your workflow? And did you consider that?
Yeah, so that's definitely something we could implement. In the demo, you might have missed it, but there was a profile page. We didn't demo it. So we think in the future we can actually add the ability for you to go in and put preferences, say like, I want to live by the beach or the mountains. And so then we can actually use those preferences to filter the listings beforehand and basically return properties that we think are really relevant to you, not just generic aggregated listings.
Okay, with that, well, let's thank these guys one more time.
Test 1, 2.
Okay, so our next presentation, the team name is Man Squared. The title of the presentation is Nomads, Navy Operational Machine Auditing Development Suite, and they are sponsored by the Navy, NavAir in particular.
Good afternoon, everybody. My name is Nick, and I'm here with Matthew, Andy, Nick, and Max. And we're here today to talk to you about Nomads, the Navy Operational Machine Auditing Development Suite. So if any of you have watched news in the 21st century, you've probably heard about cybercrime and hackers. Cybercrime is a big deal. There's over 1 million happening per day, and they cost the global economy an estimated $1 trillion with a T per year. One of the main types of cyber attacks is data breaches, wherein a hacker gains access to your network and downloads sensitive data such as credit card info or passwords. I'd like to take you to better illustrate the exact problem we're trying to solve into the shoes of a network engineer. We'll name him Kay. Kay's boss comes to him. He works in a big building with a ton of computers, like a data center, and he says, VS Code is compromised. There's a backdoor in it, and I need a list of every computer that has VS Code and every computer that computer has talked to. And I need it as soon as possible because we're in serious trouble. So Kay's like, all right, I can do that. Maybe I'll gather it manually, maybe not. I don't know. What's out there? What solutions exist? Maybe he'll use an endpoint detection and response, which is a pretty standard network monitoring platform from most cybersecurity companies. The problem with that is that it's A, expensive, B, it's not specialized for the task he needs to get done, C, it's time intensive to set up and install and get support for, D, it's got a large footprint, it's on every computer in your network, taking up cycles that could be used for better things, and it's a third-party system that if you're a security-minded company, you don't want to introduce more variables. So that won't work, so he thinks maybe I'll collect it manually. But in real life, as we've learned, it can take months for large networks to get audited in this way.
This is where Nomads comes in as an automated, low-cost, small-footprint network auditor and visualizer. But what does that mean exactly? Well, one, Nomads is automated. You don't need to be a network security specialist to use it. It works at the press of a button. Two, it's low cost. This isn't enterprise software. There's no licensing fees, monthly payments. You don't need to keep a team of specialists on retainer. And three, it is small footprint. It runs on only one computer and doesn't require a lot of processing power. So Nomads works using what we like to call the FP2 framework. First, it fetches data from the network using host discovery scans and network auditing. Then it processes that data in the back end using approved program searching and neighbor graph generation. And finally, it presents that data in a variety of formats, both visual and textual, which are easily exportable or downloadable.
Now, before we demo, I'm going to highlight a few of the technologies that we use to make Nomads possible. Nmap is our network mapper. It allows us to discover hosts on a network. Now, we have these hosts, so how do we do stuff to them? We use Ansible. Ansible is a IT automation software. How it works is you pass a playbook, which is just a list of arbitrary IT tasks that you would perform on different devices, things like logging in or gathering software and hardware information. We run Ansible on all the devices on the network and then compile these facts. We use a Flask API to run these two tasks, and then we take this information and present it in a Vue framework. Now, I'll throw it over to Matthew and Andy so they can present the demo.
Okay, so now that we're at the Nomads dashboard, we're going to need a couple things to start the application. First, we'll need a set of credentials. So if we navigate to the Credentials tab, this is where users can add, edit, or remove credentials for the different machines that they'll be logging into. Next, we'll need a set of hosts, so we can navigate back to the dashboard and take a look at the host discovery panel. We're given two options here, parsing the ARP cache and performing an Nmap scan. So parsing the ARP cache tabulates a list of endpoints based on the system's previous network communications, and an Nmap scan sends out TCP or UDP packets and tabulates lists based on who responds to them. So for a user to perform an Nmap scan on our application, we give them the option to enter an IP range, a CIDR block, an Nmap string, and then they can specify TCP or UDP, and then finally specify the ports. Now, as this is running, our application takes this list of endpoints, determines their device type by looking at the ports that are open using Netcat, and then assigns credentials based on which logins work, using Py1RM or Paramiko.
All right.
Now
You can see it just finishing up right here. So once we have an actual list of hosts, what we can do is we can upload, we can actually start to run an audit. So, host discovery finished. What we want to do is we hit this run audit button, and we can upload a list of approved software. So if I just click this button here, I can get a list of approved software. And so I'm just uploading a very simple list right now. And so while we can see this, we can see the audit running in the background. So this is running Ansible, running the playbook as we mentioned earlier. And so the way this works is this is logging into all of these computers here. And it's gathering the software and hardware information from those and then putting it all in a list together so that we can do something from it. Now, it's probably a good time to talk about what exactly it is we're scanning here. So what we have set up is on AWS GovCloud, we have around 30 machines set up, and they're separated into 2 different subnets. So the first one is one that only has Ubuntu machines. That's the 10.0.1 network. We also have the 10.0.2 network subnet, which has Red Hat machines and Windows machines on them. And basically, when this logs in, it runs a different script depending on what distro it's running on or what operating system it's running on to collect all that information. And with the help of Ansible, we can take that data and collect it all back to the command and control machine. Not only do we gather the hardware and software information, though, but we also gather the network information. So like I was talking about the subnets, these subnets can get automatically detected by our software, and then we can take that and use that for diagram generation later. We also detect what each of the computers that we're logging into can see as their neighbors. So we go to that second level of network searching, and so we not only can see what our computer can see, but also what their computers can see, and we can also turn that into a visualization later. It's all part of the FP2 process. Combine that with our approved program search, we can take that and we can add that, we take that, all those lists of software that we get, we process them together, and once that's done, we can present that in a nice format. So it's probably a good time also to talk about like the bigger picture here. So this is our main innovation, is the combination of host detection and then host evaluation. So this combination of putting those two things together is something that no other software really does out there. Well, actually, technically, according to our mentors, there was one group that did this once, 20 years ago, one time, and was never heard from again. So, while we finish up here, we're just processing it here, and you can see here that this is just adding the, getting the hardware data. It does it once for Linux, does it once for Windows, and it generates that and puts that into a table format, puts it into a diagram. It's all part of the second part. If this is the F, what follows it immediately is the first P, the process. And we're just finishing up here as it's finding the subnet mask in order to find that network information and finding the neighbors and the IP data. So, as I finish here, you can see that little loading circle about to finish up here. Give it a second. Yep, there we go. So you can see these hosts are highlighted in red, and that means that because our very short approved software list, which only has 2 softwares, like this AWS Tools for Windows here, which is highlighted in black because it is approved, any computers that have something that isn't approved is highlighted in red. And you just go through here, you can find all the different devices and all the different softwares that are installed on all of them. And for example, like on this machine, we can see that this 10.0.1.9 has Wireshark installed, but these other ones do not. And so what if we want to take this information and put it in a more visual format?
So as Matthew mentioned, the network we were scanning on had 2 subnets, one with Red Hat and Windows machine, and another with just Ubuntu machines. This is a visualization of that. As you can see, we have 2 representations of each of the subnets. Now, we can click on one. This is the one with Red Hat and Windows machines. You can hover over one of these icons and then look through a JSON formatted list of information. It's things like what software is installed on the device, hardware details, and what neighbors it's connected to.
And what if we want to take that information into a more exportable format? Now, this is the other main part of our program, the present part of FP2. And so here's an automatically generated network diagram made in Dry.io. And so basically what this does is that we have you can see here the subnets are divided into this one with the Red Hat and Windows, and down here with Ubuntu. Now, because this is a virtual network with not much real work going on, there's not much in the ARP caches of those computers, but you can see down here that I did log into a couple of them and have them communicate with each other, and you can see that represented in these automatically generated arrows down here. You can also take this diagram and basically edit it and provide out a couple different pieces of information that you might want for different types of visualization. So for example, you can just change the title. You can change the classification level, which is for the Navy, with this is a classified or unclassified network. And you can also change the region type, so right now we're automatically generating regions of blocks of computers based on subnet, but you can also put them based on machine, based on name, or by machine would be each machine gets its own region, or by name, which is you sort them by name. You can also then export these into either Visio, Dry.io, or just an image in a PNG format. That's for the visualization side, but we can also take that information and export it in the form of a table. So we have this nice hardware list down here, and if we click the Show Software button, we can also load up all the software that's on all of our devices, and that can give us a list of, there we go, of all the software that's there, and we can export that in a nice CSV.
So, what is Nomads? Nomads makes it easy to compile large hardware and software lists for complicated networks. Nomads produces beautiful visualizations that are interpretable by both the veteran IT professional and the everyday Joe in the Navy who needs to make informed decisions without a lot of prerequisite knowledge. These insights are shareable in a variety of formats, and they can be distributed in a variety, like a list and in the Visio format that Matthew showed. It's fast, cheap, and easy.
All right, so I'd like to take you back to our network engineer real quick. He's seen all this info about Nomads, and he's very happy. It's going to save him a lot of time and a lot of stress. And we've also heard a lot of excitement about this from multiple real-life stakeholders, such as the NOCWD, who's our sponsor. We have quotes from them saying that they are very excited to introduce this in their research and development networks to audit them for safety features. And we've also heard from Dr. Miller, the head of IT and cybersecurity for the Naval Surface Warfare Center, who's very interested in deploying this on NAVC networks. But one of the best things about Nomads is that we've built it to be very modular. The technologies we've used are very powerful and modifiable. So in the future, we'd like to add a lot more features, such as advanced software filtering, moving beyond simple whitelists and blacklists. We like to add continuous network monitoring, so you can watch the network to see when devices connect and disconnect. And we like to increase the customizability of our diagrams in order to make them applicable for a lot more situations. I'd just like to thank our mentors from Navarre, Mike Cloud, Kevin Burke, who's over there, Angel Zamarone, and Doug Bradley, who's over there. And from UCSB, we'd like to thank Professors Krintz and Sue, and obviously our TA, Mason Corey. Thank you for listening. Are there any questions?
Do you have any questions from our juniors, please?
Okay, I'm going to be a little bit biased because I work in network and infrastructure monitoring, just a little bit. So you guys, this is a really great demo, and I'm actually a little bit jealous because we're not FedRAMP certified, so I can't do any of this right now. But I do have a question about, you're delivering a lot of data, and this is something I'm thinking about on a day-to-day basis, so I'm curious about your thoughts. Transitioning from delivering a lot of data into delivering more actionable insights, and time to resolution is a really, you want to remediate issues, especially security vulnerabilities, as quick as you can. So what are your thoughts around making sure that you can put the most crucial vulnerabilities, in the network monitor or the network engineer's face, right?
Yeah, so like right now, like our approved programs list, right, it's a very simple implementation of that. But yeah, in the future, like we saw, we'd want to put in more ways. Like for example, something that's very specific to the Navy is they give like approvals for certain softwares only for a limited time frame. And so yeah, in the future, we want to be able to add that and have that highlighted towards the user much more than it is now.
Thanks, great presentation, guys.
Echoing, great presentation. It seems like you guys have all your boxes checked, like you really know your stuff, but it's never as easy as it seems. I was wondering if you could just comment on what one of the biggest challenges was that you had to overcome in this project.
Yeah, I would say one of the biggest challenges we faced was the network topology diagram that Matthew was the head of. What he had to do was basically, there's nothing out there for exporting diagrams and pictures into Microsoft Visio, so we had to reverse engineer the XML format of a draw.io file, which took pretty much the entire project because it's very confusing, and figure out how to get us to be able to export into that, and from that go into PNGs and draw.io files and Visio. So I'd say that was a big challenge. And the other thing is that learning new technologies, like Ansible, unless you're an IT professional, you've probably never heard of it. None of us have when we started. So I think it was very rewarding and challenging to learn those new technologies.
Yeah, great problem, great presentation. I do think the amount of data that you're showing, I think, makes it very hard to scale. And is there a view that you could drill down, like more dashboard view, where you could have prioritization? I think that may make this a little easier for the network engineer, because depending on the persona that's using this, it's probably less talented people than yourselves that are doing this.
Yeah, that was one of the big focuses of our project, right? That's why we have so many different ways to view it, right? The topology, the interaction, right? And also like a table view, and trying to be able to search the hardware and software list. There's no prioritization right now, but yeah, that's something we can add in the future. And just trying to make it easier and easier and easier, because you're right, there just is so much data out there.
Yeah, and then the other thing was, and I was saying this for a use case that I had in the past, is location of the unit that you're tracking. Things that are, is that something that you thought about gathering, not just hardware, software, but actually where that thing is?
So that was originally one of the things that our mentors wanted to add, but through our development process, we realized that like trying to find like the exact room in the building, for example, that the computer was in was not really feasible without some sort of either security concerns involved or already inbuilt schemes. So that's what we have the name diagram scheme for. Like if you name your computer based on a certain where it is, you can do that to figure out where it is. But otherwise, like geolocating things also provides security risks, because especially since it's the Navy. That's why we didn't want to do something like that.
That's great. Thank you.
Okay, next up, the team name is Panda Team. Present a talk entitled Talk, T-A-L-K, and their sponsor is Invoca.
Hello, everyone. Thank you for coming to our presentation. Our product name is Talk, and Talk stands for Transcripts, AI, Logs, and Keywords. Our team name is Koki's Cookies, and I'm the team lead Koki.
I'm the scribe Brian.
My name is Adarsh.
I'm Sharia.
I'm Sydney.
And I'm Zion.
And our sponsors are Invoca, and special thanks to David, Rachel, Enon, and Lauren. So today we have two sales agents from Nintendo. Brian is a sales agent who utilizes Talk, while Sydney is a sales agent who does not.
Hey Sydney, how's work been going?
Work's been super busy. I worked overtime today, sorting through the 35 calls I made, but I don't even remember what I talked about.
Wow, 35 calls. Who here in the audience has ever taken 35 calls in a day and remembered every single key information in it? Wow, no hands. Can I get a little hands up if you've taken a call like last week and remembered every single information just for that one call? Oh, look at that, one audience. The point I'm trying to drive here is that it is extremely difficult to take notes on every single key information from a call. And so some people might be thinking like, then why doesn't Sydney just take less calls, just aim for like 20? However, in reality, the average sales agent takes around 35 calls in a day. So Sydney is trying to meet the norm.
How's work been going for you, Brian?
Oh, work's been super good. I took 60 calls today, and I was even able to leave work early. Life is great.
Wow, look at him, 60 calls. Now, some people might be thinking like, well, Brian's just a better sales agent, making more calls, making more money. Well, in reality, a mere month ago, Brian only took 20 calls in a day. So what exactly changed? Well, Brian started to use Talk.
Oh, hey, wait, I'm getting a sales call right now. Hello, this is Nintendo.
Hi, I was talking to an agent named Sydney the other day, but I wanted to call back, but I never got one.
It's okay, I can help you.
Oh, great. I'm looking to buy a Nintendo Switch. What deals do you guys have?
Yeah, so we have a buy one, get one free deal or a bundle deal. Which would you be interested in?
Can you tell me more about the bundle deal?
Yeah, of course. The bundle deal comes with a Nintendo Switch, a Pro Controller, and Super Smash Bros. Ultimate. Would you be interested in that?
Yeah, that actually sounds great, but I want to check with my wife first. Can I call you back?
Yeah, of course. Talk to you soon, bud.
Later.
I had a customer call me earlier this week also asking about what deals we have, but I don't remember the call details. I don't even remember this guy's name because all I have are these really poorly written notes and this unknown phone number. I really wish there was a better way to handle all of this information.
Well, would you look at that? There is. I've been using this really cool app called Talk, and it's been making my sales skyrocket. I have a friend named Shaye that can tell you more about it.
Hey, Sydney. Thanks for wanting to learn more about Talk. I can start by showing you some of our key features. Does that sound good?
Sounds great.
Awesome. Well, right here is our beautiful homepage. Talk stands for transcripts, AI, logs, and keywords. And our primary goal is to improve your productivity as a sales agent. So now I'll go ahead and log into an existing account to show you some of the awesome stuff we provide. So we'll go ahead and log in here. And after the page loads, you'll see our call log page. This is our main page, and this is where all the magic happens. So now I'll go ahead and pass it on to Zion and Adarsh, our two product specialists, to dive into some of our key features.
Yeah, of course. So when a customer calls a company, these calls get routed through Invoca. Talk essentially gets these transcripts and extracts the keywords, sentiment analysis, and summary. Invoca uses IBM Watson to transcribe these calls. So as we can see here, this is a sample transcript, and there's a clear agent and a client to distinguish between the two callers within the transcript. At Talk, we believe that it is important for the agent to focus on the client rather than taking down tedious notes and details, and that is why we have included this feature within our application. In addition, if you as an agent want to reference this transcript at any time in the future, you may do so by simply going to our call log page and going to this transcription. Talk also includes the most important keywords from your transcriptions using Google Cloud technology. Some of these keywords can be locations, client names, products, and companies. So for example, in Brian's conversation, the most important keyword was the Nintendo Switch. So we can see that as one of the most important keywords within that section.
Another key feature that we want to show you guys is our sentiment analysis. We extract the sentiment from Google Cloud, and it can range from very negative to very positive. The sentiment analysis is important because it allows the agent to tell the mood of the caller without having to reread the entire transcript. Then, if the sentiment is positive, it can help guide an agent's decision in callbacks. Lastly, look, the call today we witnessed was relatively short, but some sales calls can go for hours. Talk provides a short and concise summary using NLP cloud summarization. This allows the user to get a gist of the overall call without having to reread the entire transcript.
One last feature I want to show you guys before I hand it off is our handy search bar. This allows you to skip scrolling through countless call logs and get to the call log you were looking for immediately. So, for example, if Brian remembers that he had a conversation about the Nintendo Switch but can't remember any other details, he can simply go to the search bar, type in the word Switch, and he'll be brought to the call log he was looking for immediately.
Oh my God, that was a lot of information. You have any questions, Sydney?
Yeah, I had one quick question. After I finish a call, when does that show up on my call log page? How long does that take?
So it can vary, but what we like to say is the transcription is about 1-to-1 with the call duration. So let's say a sales call was 2 minutes, then the transcription is going to take around 2 minutes as well, and then we do some other computation ahead of that as well. Just to speed things up, we do have caching on both the front end and the back end.
Sounds good. How can I sign up?
So sign up is super simple. All you have to do is go to our registration page and input your information. From there, the process is complete. And after you do that, you can go ahead and log out and log back in again, just to make sure that your information is saved and the registration was completed successfully.
Looks like I'm all signed up, but I did accidentally register with the wrong phone number. Is there a way I can fix this?
Yeah, sure, that's no problem. You can go ahead and navigate to our profile page. From there, you can change any information that you registered with just one click of a button.
And looks like it's saved. Is there a way I can put my past call logs that I took without Talk onto Talk so that they can be in the same place as my future calls?
Yeah, of course. So if you had any handwritten notes or used a phone number that wasn't associated with your account to make a sales call, then you can use our add call feature. All you have to do is enter the customer phone number as well as the transcript, and we'll take care of the summary, sentiment analysis, and keywords on our end. And it should pop up there after the call loads.
And it looks like it worked, but it's almost perfect. I did make a little typo in the transcript.
You're all good. We all make mistakes. You can go ahead and edit any call you want, anytime you want. I use this feature to sometimes add notes to a call after I make it, or if anything looks incorrect.
Sounds good. This was really easy. I can see how Brian's productivity shot up really fast.
Absolutely.
Yeah, so after using Talk for just 1 month, Sydney was able to boost her productivity level even higher than ever before. She now takes 70 calls a day and is able to be the most efficient worker in her group. Talk generates key features to help sales agents create more client-focused solutions. These are the keywords, sentiment analysis, and summary. And these all work together very well. For example, you can see which keywords led to the best sentiment. You can see common reasons why customers call, or you can also see the public sentiment towards a specific product, among many other things. Talk is a one-stop platform for all your calling needs. Whether you have a large client base or just want to remember calls better, you can use our service. It's super simple to use and intuitive to understand. For example, if you wanted to take customer service calls or remember your family conversations or work conversations, you can use our service. That basically concludes our presentation, and thank you for listening to our talk.
Now we want to invite Mason to give a call, and we want to show you kind of like a live demo of this happening.
Hi, I was wondering if you have any campus tours for the upcoming spring?
Yes, we do. On average, we have about 3 time slots available every day throughout the upcoming months. However, they're available on a first-come, first-served basis.
Okay, sounds great. Do you have any for the Monday on March 28th?
Yes, we do. The available time slots are 12, 1:30, and 3. Which would you prefer?
Oh, great. Can I reserve a spot for 1:30?
Okay, I just reserved a spot for you. Is there anything else I can help you with?
Yeah, I was wondering around how many people are going to be placed in each time slot?
There's approximately around 20 people per group.
Great. Thank you so much for your help and your time.
No problem. Hope you have a great time on your visit.
Bye.
Okay, while that's processing, I'd like to answer any questions you may have.
Let's thank these guys. Any questions?
I know I asked you guys this earlier, but I wanted to pose it to the broader team. Where do you see something like this fitting in with something like Outreach and Salesforce?
Yeah, so of course, those are huge companies. Outreach and Salesforce are titans in the industry, and as a small organization, a small company, we don't think we could take them on, but what we would want to do is add features that they might not have, like the summary, sentiment analysis. Those 2 features integrating with platforms like Outreach and Salesforce would be really useful for sales agents.
Great presentation. I liked the demonstration you guys did. You might have mentioned this, but how do you guys assess the sentiment?
Oh. Are you asking like, yeah, so we basically go through the Google Cloud API. The Google Cloud gives a score for sentiment. We created about 50 or so fake transcripts based on real calls. And then we sort of had a rating system for all of them, whether that was them being very positive, very negative, or anywhere in between. Then we fed that to the API, and then we manually sort of figured out at what point we wanted to set our specific thresholds at.
In your presentation, you talked about basically doubling your capacity to take calls. Do you have any metrics that actually could validate that?
Sorry, can you repeat that question?
Yeah, in the beginning when you did your presentation, you essentially said you could double your capacity to take calls. I'm curious if you did any validation to show that was true and that you have metrics around the productivity and that you're closing that deal.
Yeah, so we did research on around how many calls sales agents take, and the average sales call was like the 35. And then we also did research and found out that efficient sales agents take around 60 calls a day. And we didn't have time to do like actual research and like ask out sales agents and then integrate this with their workflow and stuff.
Mm-hmm.
But in the future, we wish we could do that. And so based on like a lot of factors and research we found online about like if they did have a efficient workflow, they like guess around like 70. So that's where we got those numbers.
Thank you.
Also, the call log loaded from last time, so we'll just show that on screen.
And it works. Thank you, guys. Okay, next up, team name, Inspector Royale. They're going to be telling you today about their project called Recommendation Monkey, and their sponsor and mentors is Bill.com.
Hello. Hello, everyone. We are Team Inspector Royale. Our project name is the Recommendation Monkey, and we are sponsored by Bill.com. My name is Derek. This is Noah. This is Joe. It's Carson, and there's Jonas all the way over there. So Bill.com, they gave us about $36 billion worth of transaction data. Our job, analyze and predict. We're going to do that through data analysis, data engineering, and statistics, so that we can give you a business recommendation with explainability. So for the first quarter, we focused on making the back end and our own algorithms for analyzing. And the second quarter, we focused on scalability so that we can work with data in the tens of millions. How we did that? We made a home for the data. Then we turned that data into information. And with that information, we got graphs. And with those graphs, we can predict and give you a business recommendation. And here's Carson for the Jupyter user experience.
Now, as previously mentioned, a key feature of our application is scalability across hundreds of industries, as well as simplifying our results. We did that by giving the user multiple opportunities to select fields related to the businesses that they would like to analyze. To begin, the user may use a drop-down menu to select a Bill.com defined archetype. A Bill.com defined archetype is a general classification of related industries. Here we will select general service businesses. Next, the user may see a multi-select menu where they can select up to any number of industries within that archetype. Here we will select a handful of industries. Finally, the user will see a radio button to select between small businesses or large businesses.
A small business has 1 to 25 employees, while a large business has 26 or more employees. Here we will select large businesses. As we fulfill these fields within the get a report part of the page, Jupyter is calling our Python code in the report page to perform our calculations. Here we select get a report to go to the report page. And first we will see all the selections that we had previously made. And next we will see a general summary between the small and large businesses within the industries that we had selected. Here you can see that there are actually no small businesses, meaning there are no businesses with 1 to 25 employees within these industries as indicated by the total payment count. However, for large businesses, there's north of $600 million in total transaction amount. These 5 statistical methods were used to perform our analysis and eventual recommendations. Let's talk to Noah to learn more about k-means clustering and derivative analysis.
So this method is actually a collection of 4 sub-methods that we run on every industry to give you a better view of how it performs in terms of growth potential. But for brevity's sake, we're going to look at these 4 subgraphs on one example industry, that being the information industry. As you can see here, we use k-means clustering, which is a simple classification algorithm, and it identifies 3 distinct clusters here, each denoted by a faint cluster center. And we see that there's distinctly 3 tiers of transaction amounts going on. We have the green tier 3 companies, which are low transaction amount, high transaction volume. We have the blue tier 2 companies, which are medium transaction amount and medium transaction volume. And then finally, we have the far and few between tier 1 red companies, which are very high transaction amount, very low transaction volume. But actually, we're interested in the tier 2 companies because we believe that by studying the rate of growth of these middle tier companies, it serves as a general indicator for growth potential in the industry. If we identify many companies within this tier that have a high rate of growth, it shows the overall tendency for entities within this industry to regress towards becoming tier 1 companies, and thus serves as an indicator for upwards mobility within this. And so we'll do exactly that and investigate the middle cluster. As you can see here, it's another scatter plot with some added linear regressions. This time it's just been constrained to the middle tier that we were discussing. As you can see here, it's generally positive trend. However, this doesn't give us a big enough picture. So let's go one step forward and let's investigate the net change in transaction velocity. Transaction velocity is simply defined as a rate of change of transaction amount over time. As you can see here, a large negative value means that they saw a large decrease in their rate of growth over the last 2 years. And as you can see, across the industry, it's a generally net negative presence, meaning that our example industry of the information industry saw somewhat of a decrease in their rate of growth over the last 2 years. But let's go one derivative higher and investigate the net change in transaction acceleration of middle cluster transactions. And as you can see, it sort of flips here. The entity we saw earlier exhibits a very high positive presence, and we see across the industry it's generally positive, meaning that the information industry, while its rate of growth may have slowed down, there is still a possibility for future exponential growth. And we actually see that reflected in the results here. When we rank industries according to transaction velocity, you can see the example industry information ranks quite low, as expected. However, in terms of transaction acceleration, it ranks quite higher. Though we are particularly interested in industries that excel in both, such as educational services. And you'll see this factored into our final recommendations. And we also did a side experiment because performance and scalability was such a concern this quarter. We ran this experiment on a laptop that had both a GPU and a CPU to compare runtimes. We used k-means clustering across all industries, because typically a very computationally expensive procedure. And we found that the GPU reduced the runtime by about a factor of 10. And then paired with software optimizations, we're able to get the average runtime for algorithm per industry down to about 300 milliseconds, close to the Google standard of 100 milliseconds, but closer the better. So we recommend that if you're to try to replicate these experiments, to use a dedicated GPU. And to investigate the next method, I'll hand it over to Joe.
Thank you, Noah. So this is just a general date versus transaction amount over 20 industries. We use this information to predict future 2-year transactions for top 5 vendor customer pairs. As for the top 5 vendor customer pairs, we utilize the top 5 business vendors that Jonas calculated for us. Let's pass to Jonas for regression analysis and a full examination on vendor customer pairs.
Thank you, Joe. So our regression analysis outputs best fitting function with 4th order derivatives for all the industries across years. Here, higher order derivatives signify the rate of change of lower order derivatives, which in turn shows the rate of change of the regressed function. And for the series of changing rate, it it summarizes us how the industry generally performs in the past and possibly in the future. For the case of information industry, we can see the fitting function appears to be mostly a linear increment trend, which is dominated by a positive lower order derivative. This means that in the near future, it has a steady increment trend, but in the long term, its holding return won't be ideal. Whereas for the professional and technical service industry, we see the fitting function has a mostly sinuous downward trend, which is dominated by a negative higher order derivative. This means that in the future, it's most likely going to plummet and not to be recommended. For all the transactions across years and industries, many of them are correlated with each other, which means that subscription analysis is suitable. And we use SQL's lag window function to identify recurring payments between the same vendor-customer pair across all the industries. And for each industry, we rank all the pairs by the sum of their recurring payments. And this not only gives us top-performing company pairs that integrates their capital flow into Bill.com platform, but also gives a general picture of how each industry is behaving stably across time. The result is shown in the bar graph. For the information industry, we can see 20 strongly performing customer-vendor pairs. This shows a very healthy industry worthy of investment. Contrarily, for the professional service industry, only the first vendor-customer pairs performs reasonably good, indicating a doubtful industry, but a very promising vendor-customer pair. And for this type of promising pairs, we search for them across all archetypes and industries, extract top 5, and show the results in the next slide, which is here, and we'll pass this value to Joe for further analysis.
Thank you, Jonas. We used time series to predict future transactions last quarter, and this quarter, we apply a seasonal moving average model to predict which vendors' customers' peers are increasing at certain rates. We select the top 1 business vendor customer pair and utilize the previous 3-year data to make a comparison between 1-year forecast and actual transactions. We calculate the autocorrelation between 2 inputs, and this plot indicates that we can use SREMA to forecast transactions. At first, the forecasting transactions are always under actual results. They do not quite fit each other. So we change the parameters of our model so that the actual transactions can fit the forecasting results. Next, we produce future 2-year transactions with 4-year data. The actual results can fluctuate between the upper and lower bands, which is similar to the confidence intervals that provide a range for possible transactions in the next 2 years. And this helps investors to determine the entry and exit points for their investments. Here we got predictions for top 5 vendor customers pairs, and this suggests that the information industry has the highest potential gains in the next 2 years. Let's pass to Derek for final recommendation.
Thank you, Joe. So through k-means derivatives and regression analysis, we can recommend companies with the highest potential. And for the other 2 methods, the time series analysis and subscription analysis, we have companies that are consistent in transaction-wise. And if you're looking for a little bit of both, we recommend the ones in the middle. And a special thanks to Stu, all the way over there, our mentor from Bill.com.
Questions?
Agreed, a lot of data. I mean, you guys clearly know your stuff. Definitely, sifting through all that data and figuring out how to make sense of it. I was wondering if you can give us, thinking like you're purely an end user right now, and so you don't know necessarily everything that's going on behind the hood. Can you give us an example of a use case of how this might be utilized in real practice?
Great question. So it actually might be best to view this not as a public app, but rather as an internal data science tool for the executives and salespeople within Bill.com to use. So in that use case, it would most likely be a salesperson that is trying to investigate which industries they should maybe commit more calls towards, or maybe an executive that wants to commit a sales team towards those recommended industries. So it is predicated on the user having some knowledge of their own data and what they're seeing business-wise. So it wasn't really meant for a public user who's not really acquainted with the Bill.com database.
All right, let's thank these guys one more time. Okay, so our next talk is by a team named 404, team name not found. The title of the presentation is BRAD, Biomedical Resource Assessment Diagnosis, and the sponsor company is Teladoc.
Hello and welcome, everyone. We are Team 404, team name not found. My name is Ishana.
I'm Sophie.
My name is Steven.
I'm Anthony. I'm Evan.
And I'm Caitlin.
And today we're going to be talking about our product BRAD, which stands for Biomedical Resource Assessment Diagnosis.
So I'm going to be getting us started with a little bit of background. The telehealth industry is built on providing medical care to patients without requiring an in-person visit. Since March 2020, the need for such avenues has exploded to 38 times its pre-pandemic size. Yet, according to a recent study, 50% of doctors experience symptoms related to burnout because of the responsibilities of their documentation work. Doctors with burnout are 40% more likely to go part-time and 20% more likely to consider leaving their practice altogether, making burnout a leading cause of the nationwide physician shortage.
We've identified 3 key issues that our chatbot BRAD seeks to address. The first is lack of communication. Communications between patients and physicians is essential. However, it's hard to do so thoroughly when they're not talking face-to-face. The second is wasted time. Consultation is a standard medical practice, but a lot of the questions that are asked can be easily collected in the patient's own time online. And the final is underutilized medical data. A lot of data is already being collected in the healthcare industry, but a lot of it goes unused. Our chatbot BRAD seeks to use this information to create data-driven potential initial diagnoses.
So how exactly does our product BRAD address all of these issues? BRAD seeks to improve the consultation process in 4 main ways, the first of which is with easy access to patient information. Through the dashboard, patients can easily register as well as schedule their appointments with their primary care physician with the chatbot functionality. BRAD also seeks to drastically reduce the workload of the physician and nursing staff by allowing patients to complete a symptom screening prior to their actual consultation. The chatbot then aggregates all this information, patient data, as well as symptom information to provide an initial diagnosis to the physician ahead of time. And all this data is stored within BRAD, making it super easy for the physician to go in and edit the diagnosis, as well as have asynchronous communication with their patients.
Okay, with that, we will jump into a live demonstration of BRAD. So from the landing page, we will log in as a first-time user. This will kickstart our new patient registration flow, where users can input medical information for the doctor to view later. And while we're inputting our information, I'd like to emphasize the pre-existing conditions field, because this field will actually assist BRAD in making an initial assessment of a patient's condition. And we will finish off by adding in our medication and clicking register. We will need to log out for everything to be saved properly, and we will log in as that same user. And soon enough, we will be greeted with the patient dashboard. But let's say I made a mistake during the registration flow. No problem. We can easily head over to the patient profile page to edit any information. So let's remove diabetes and click save and head back to the patient dashboard page, because we are now ready to schedule an appointment.
So let's go ahead and take a look at the bottom right-hand portion of the screen. We see this B icon. That is our chatbot BRAD itself. And we see we are greeted with 2 options. We'll go ahead and expand the page. And we see we have 2 options, one to schedule a new appointment and another one to complete a pre-consultation screen. Let's go ahead and let's just schedule a new appointment with our primary care physician. So we'll click that option. And you see we're greeted with 4 options, or 4 types of appointments you can schedule. The first being a general consult, the second being an annual checkup, third being lab, and fourth being a pre-travel consultation. Let's say that I'm just not feeling that well and I want to just have a general consult with my primary care physician. So we'll go ahead and click 1. And with that, we see Brad asks us which day we want to schedule our appointment. To display a little error handling, let's go ahead and enter a date that's already happened, so the 28th of February. And we see that Brad lets us know, hey, this date's already happened. Enter a day after today. So let's go ahead and enter the 10th. And with that, we see we're given 4 available appointment slots. Let's say we'll just take the 10 a.m. That's what works for me. We'll enter 1. And what's the reason for the visit? Again, I said I'm not feeling well. Maybe we'll just say I am sick. Perfect, the appointment has been scheduled. If we minimize the chatbot, we see that the page auto-refreshes with this appointment card and has some relevant information about the appointment, like the location, some patient information, and we also do have this pre-consult status flag. As you can see, we have not completed the symptom screening yet, so let's go ahead and do that right now.
Okay, so once the patient has scheduled an appointment, they are free to complete the pre-consultation at any point before the appointment, but let's go ahead and do that now. In the chatbot, we're going to type in pre-consult to begin the pre-consultation flow, and we are going to be given a list of the upcoming appointments for the given patient. So we see right here we have the appointment we just created on the 10th at 10 a.m. Let's select that appointment, and it's going to give us a confirmation that this is a general consult. It is. So we'll say yes, and it's time to begin a symptom screening. So I am experiencing headache. I will say yes in the chat, and I will be given a list of 7 more specific symptoms that I can select. I have a pressing headache, so I will go ahead and select option number 1. I also am experiencing cough, so I'll say yes to this as well. And again, I'm given 7 more specific symptoms I can choose from, but just to display a little bit of error handling, what happens if I put 8 in the chat? The chatbot will tell me that I have to select an option 1 through 7, so let's do that. I have a productive cough, which is option number 2. I am not experiencing any fever. I also don't have any dizziness or abdominal pain. So now that we have finished the pre-consultation flow, we can minimize the chatbot and we see that the pre-consultation status flag on the appointment card is now marked as completed.
Now, if you'll notice, the tags field for these appointment cards are also filled in. And what this is it's an aggregated list from the patient's existing conditions, which are colored in gray, as well as the symptoms that were given by the patient during this recent chatbot interaction, which are colored in purple. Now, this is here to allow patients to distinguish between appointments at a glance. For example, if a patient has multiple appointments for different reasons, they can easily know which one is for what reason. Now, if a patient wants more information for a given appointment, they can go ahead and click on one of these cards, which navigates them to the appointment page. Now, on this page, the patient has access to the high-level information about themselves, which is the patient info on the left, and in the middle, the appointment information, which includes the doctor, their specialty, the time and location of the appointment. One card right, you'll see the diagnosis information, which includes information about the chatbot interaction, such as the symptoms that the patient had just provided. Again, that pressing headache, as well as the productive cough. Now, on the right here, you'll notice that the patient has access to the chat logs. This is a synced history of the chatbot interaction that the patient just went through, and it allows the patient to look over what they gave as input to the entire pre-consult screening. Now, if you'll take note at the bottom section here, we mentioned earlier that we provide some form of asynchronous communication between the patient and the nurse or doctor or reception. This comes in the form of a comment section. This allows the patient to directly communicate with, again, either a nurse or a doctor or reception about maybe symptoms that they forgot to provide during the chatbot interaction, or maybe they never had the opportunity to at all. For example, we earlier said we were not dizzy, but maybe that's changed since then. We can now say, I'm feeling dizzy. Dizzy. And that will add a comment for this appointment. Now, if we go ahead and navigate over to the doctor's view, we can go ahead and log out of the patient, log back in as a doctor, and we'll be greeted with the landing page for the doctor. This is a time grid view of the entire week so that the doctor, or again, nurse or maybe reception, can see the entire schedule. And here, again, if we hover over any of these appointment cards, the doctor or whoever is viewing is given high-level information about that appointment without even clicking it. This includes the patient's pre-existing conditions, again colored in gray, or the symptoms they experienced during the chatbot interaction, which is colored in purple. And you'll also notice a new one that we didn't see on the patient side, the common cold. Let's click on this card to figure out what that is. When we enter in the appointment view, it's very similar to the patient's view, but the key differences here are the first in the diagnosis info card, this Brad diagnosis of common cold. This is our data-driven approach to provide the doctor with an initial diagnosis based off the patient's pre-existing conditions and their symptoms that they stated during that chatbot interaction. And we mentioned we wanted to tackle transparency. Well, the doctor also has access to the chat logs, and therefore they can also either reaffirm or confirm with the patient if they meant to answer these questions in this way. And at the end of the visit, the doctor also has access to put forth their own diagnosis, which is visible to the patient. So maybe after the visit, the doctor concluded that it is a common cold. They can go ahead and save those changes. So now that whoever visits this appointment, be it another doctor, the same doctor, or nurse, reception, or the patient, they will also see the doctor's diagnosis. And again, that asynchronous line of communication in the comments, the doctor can now, at their leisure, respond to the patient who is feeling dizzy. Maybe they say, drink some water and rest. And from there, the patient can look at the appointment, see that comment, and take it from there.
None of this could have been possible without the versatility of the framework we chose, a prime example of which is Informatica API. It's an external medical database system filled with detailed symptoms and conditions we utilize to get an initial diagnosis. Following that, we have our chatbot, Amazon Lex. It exchanges information between itself, our database, and Informatica. Lastly, we have DynamoDB and Next.js, responsible for our backend and front-end models, respectively. So, what's next for Brad? Further implementations to be seen would entail medical vocab assistance for our patients on more complex medical terminology. Following that, Brad has the potential to map patients with a physician that can more better suit their needs. Another feature would be push notifications, in the instance that maybe you completed a consultation screening, or the doctor had added a new comment. Lastly, our product meets the needs of before and after a consultation, but the most significant improvement would be the full integration of the telehealth screening process from beginning to end, with both video and audio included.
So to conclude, we believe that our chatbot Brad will have a significant impact on the healthcare industry due to several reasons. The first being that we employ data to assist in making medical diagnoses. This will help physicians save time when they meet up with their patients during their appointment, thus leading to increased transparency and efficiency. This also reduces the need to ask redundant questions from the patient that can be collected online in the patient's own time. This allows physicians to give faster care and also be able to reach more patients as a result. This leads into our third positive impact, which is that we improve on the automation of routine medical services. Due to all of these reasons, we believe that using Brad to facilitate patient-physician relationships will be extremely beneficial, not only in increasing transparency and efficiency, but also in adapting to the ever-changing field of healthcare, especially in the context of technological development and the COVID-19 pandemic. It is essential to assure that communication and understanding is available to patients in a telehealth context.
And with that, we want to thank everyone for listening, and we want to give a big, big shout out to all of our Teledoc mentors, especially John and Sushil, as well as all of our UCSB mentors. And with that, we'll take any questions. Thank you.
Great presentation. And I agree with the sentiments that you had at the end. I have a couple of questions. The audience, the patient group that you're thinking about, when I looked at some of the responses, like productive cough and things like that, did you take that into mind, how people would understand that from the chatbot? I know you're pulling it from the dictionary, but your personas that you designed this for, especially older patients, did you think about how they may react and be able to use this tool effectively?
Yeah, so that's actually kind of one of our roadmap features, that medical vocabulary assistance. We understand that some of these terms can be like kind of hard to understand, and eventually one of our goals is to, like you say, provide assistance for these clinical terms that maybe the ordinary Joe might not understand. We don't know what form that comes in terms of user interface yet, but that is something that we hope to improve on.
Yeah, and then my other question, when you think about the type of personas that will be using this, how do you protect their privacy? I know you had a login, assuming you don't have a mobile app yet. Would you think about biometrics as a way of simplifying that? Have you thought about how that could be integrated?
Yeah, so again, I think it's pretty difficult just in the healthcare space in terms of privacy and security. We know that's a super, super big deal. And so what we have here is obviously right now not like HIPAA compliant, but the idea is that, we can integrate this into existing healthcare systems who already take care of user data at, the highest level of discretion. And so pretty much wherever, like whatever company or sector uses this type of technology, if they allow for biometric authentication, like fingerprint or Face ID, then I'm sure that is I guess it's probably on them to figure out that form of security and the way they store that type of data. Yeah.
Also, a little bit more on that. We are not fully HIPAA compliant by any standard, but DynamoDB and Amazon actually is, as a database, HIPAA compliant.
Yeah, thank you. That was one of my questions.
Great presentation, and I think it's a great idea. I mean, I can speak from experience as a patient. I think probably most people in this room have been a patient at one point in time. Onboarding can be difficult. Like, it's hard enough to get us to go into the doctor's office, let alone download a new app or respond to a text. I'm curious if you've thought about how to kind of motivate onboarding and actual engagement.
I'm sorry, do you mind repeating the question? The echo kind of got to me.
Have you thought about the very first point of usability of just getting patients to use this, how to motivate them to download the app or respond to a text?
Yeah, I think one driving factor right now is like, whenever you have to schedule an appointment, you go to someone's website and it's like, okay, call this number. So then you call that number and then you wait in some queue to finally get to a receptionist to maybe explain your problem. And then they take that data only to make an appointment, and then you have to find out, it's a whole interaction just to get an appointment down, right? When these things can easily be automated or done virtually, because who better knows how to schedule out a calendar than, AI or scheduling algorithms. Furthermore, with the direct line of communication, this asynchronous comment section, it allows people to not wait in online chat queues or online phone queues for that matter. And so instead of waiting for, I'm the 19th person in line, 18th person in line, you just send your message, and when the doctor or nurse or whoever has the free time to respond, they'll respond to it and you can check back. And again, one of our features is push notifications, so right now that's not implemented, but the idea is if someone responds to this comment, you will be notified and you can just check again at your free time, and you'll have the response you're looking for, or if not, it's a whole conversation. So you can go back to them, can you clarify, back and forth. And the idea is to improve efficiency as well as, again, that transparency between the patient and the physician.
Yeah, to kind of add on to that, it's not just having a specific patient download it, but rather having a whole practice move over to using something like Brad, just because you would need the physician also have they have their own view of the portal as well. They're keeping track of appointments and the tags and the Brad diagnosis. So it's not necessarily on the user, the patient itself to download this type of thing. It would be trying to help the whole end-to-end process, both the patient side and the physician side. Again, with decreasing all that workload, we really want the product to refocus the physician back on the actual work that they're doing and not the paperwork and things like that. And then same thing, like Stephen was mentioning with the queue of waiting for a call or talk to reception or this or that. I don't know, but I've been on hold for 10 minutes just to schedule an appointment. So this is definitely to help just streamline that whole process.
Okay, our penultimate talk for today, so second to last, I'm sorry, yes, all yours. The next group, their team name is C++, spelled SEA++. Their title of their talk is Augmented Reality and Maintenance of Ship Systems, and they are mentored and sponsored by NAVC.
Stay here. Okay. Hello, everyone. We are Team C++, here to tell you a little bit about our project, Augmented Reality and the Maintenance of Ship Systems. So I'm going to go ahead and introduce the team. Hello, my name is Luda Panina. I am the team lead, along with Vivian Ross on the end there. She is our scribe. Kyle Cam, manning the slides. And let's see, Emilia Mahoney and Tao Fan. And our sponsor is NAVC, and our mentors include Alan Gager, Christopher Leslie, and Clay Gronke. So allow me to set the scene for you a little bit in terms of the problem we were trying to solve here. So Navy ships contain many systems that vary in age and levels of wear and tear. we saw these ships. They are very interesting, and they have a lot of different systems, and, some of these ships are pretty old. And occasionally these systems break down and require maintenance. And when this maintenance is beyond the crew's training, then experts need to be flown in onto the ship, which is both costly and time-consuming. So the solution we've been working with is to use augmented reality with the HoloLens 2 in order to guide untrained users through the maintenance and verify that they have completed those steps correctly.
So there are multiple routes we could have taken in integrating augmented reality into this problem, which goes to show just how versatile AR is. Our first option was to essentially create a communications app. What this would consist of would be, we'd essentially have an untrained user on a Navy ship put on a HoloLens and video stream what they're seeing to a remote expert on land. The expert would then see this video feed and be able to annotate it, maybe highlight some pieces of machinery or add some shapes, things like that, which the user would then see in their environment through the HoloLens. In this way, the expert would be able to walk the user through some sort of maintenance and be able to perform the procedure in that way. However, there are a couple of problems with this, in that, first being that the Navy ships don't have very much bandwidth, so we weren't sure about the feasibility of streaming a large amount of video from the middle of the ocean. Second being that this isn't very novel. Several companies have already been working on similar communications apps. And so we decided to pivot a little bit and switch to creating a self-contained application, which essentially consists of an application that contains a 3D CAD model of whatever system that the user is working on. The application would also have instructions pre-programmed into the application for the user to follow, and it would be able to verify that the user has actually completed the instructions correctly and provide the log for an expert to look at later. We used Unity and the Mixed Reality Future Toolkit in order to implement this.
So let's talk a little bit about the user experience. So when the user first loads up the app, they will see a set of instructions on how to use the app and the HoloLens in conjunction with the app. Once they have read through all these instructions, they will see the virtual board model that we have created, which is a one-to-one model of the physical board. We chose to make a board model here because it's supposed to represent the Navy ship equipment, because for the scope of this project, we don't have access to that just yet. So when they see this model, they have to align it, the virtual model, on top of the physical object they're supposed to be working on, either by manually dragging it or using the script that we have created to basically snap the board onto place. And once they have finished aligning the model, they can choose to start instructions by rotating their left palm and clicking the start instruction button, at which point the instruction will pop up on top of the board and they can begin their execution. And while they are performing these instructions, our app will be monitoring and logging their actions to be able to verify that they have completed the instructions correctly. And once they have done so, our app will play a sound to let them know that they can move on to the next instruction. And I will leave it to Emily to talk more about the verification methods.
So the verification methods are the real novel part of our app. We're taking it a step beyond just assisted instructions, assisted maintenance, and actually ensuring that the user has feedback on whether they're doing the steps correctly. So we have a couple different methods. The first is eye tracking. So the HoloLens will actually follow the gaze of your eyes. It'll see where you're looking on the machinery that you're operating on to make sure that you're looking at the right components for that step. The second method is hand tracking. So the HoloLens will track the position of your hand in relation to the machinery and make sure that you are either touching or at least in close proximity to the right component at that time. The third one is gesture tracking. So some components require specific hand gestures in order to be completed correctly. For example, the knob on our physical model requires that you turn your wrist when operating it instead of just touching or looking at it. And so all of the information about these three things are kept in a log that gets generated at the beginning of every instruction sequence with timestamps and the instruction that you use. So there's information on what you've touched, what you've looked at, what gestures you've performed, and what times you did all those things, so that there is an offline record after you've completed the maintenance of what you did. And this is really helpful. It's really valuable for troubleshooting, because if something goes wrong, you have that existing record of what you touched, even if it was the wrong component. So you can always go back and diagnose where the problem started.
So one of the great things about our app is that the idea of actually overlaying a virtual CAD model onto its physical counterpart is actually really versatile in its applications. So not only can you use it in the context of ship maintenance on board a Navy ship, but you can also use it in an industrial context when you're trying to train someone for using tools, or for just any general purpose heavy machineries. And in addition to this, you can also use this in your own homes. So let's say, for example, that you have a refrigerator that's not working properly anymore. Now, usually, you could find someone who's a maintenance person. You could schedule them to come to your house. They would come to fix your machine for you, and then they would leave. But you could shortcut all of that if you have the instructional model for your refrigerator in our app, and you can do all the repairs yourself without having to do all the busy work of ordering someone to do it for you. And thirdly, our app really emphasizes a design pipeline that allows new models and instructions to be uploaded into it. And once the model is uploaded into our app, you can use the verification methods that we've designed and attach them to the individual components that the user is supposed to be interacting with. And if you pair these verification methods with the logging that we've also added as well, it creates a feedback loop that lets designers really fine-tune the instructions.
At this point, we'd like to show a video demo of what our application looks like to a user. Before we start, I'd like to point out that the HoloLens has several cameras used for different things like gesture tracking, hand tracking, and the camera that is used for recording is not exactly where your eyes are located, so there is some slight parallax error in the video. But yeah, first thing you see when you open the app is a couple of pop-ups with some basic instructions. Once you kind of click through those, you will see that the first thing to do in order to start anything is to open a hand menu, and that consists of just rotating your palm towards you, and a series of buttons will come up. Then you want to align the virtual board with our physical board. You can see in this video that you're doing this by tapping 3 corners of the board and then off-camera pinching your left hand. Once you pinch to confirm, the virtual board will snap into place just like that. Then you're going to want to open your hand menu again and hit the top button to start the instructions. You can see the instructions appear above the board, and the component that you're expected to interact with in that instruction is going to be highlighted in blue. Everything that you gaze at will turn green until you gaze at the correct component, in which case it will then stay green. In addition, once you've looked at the correct component and then touched it, you will see that within the instruction block up there, an OK button appears to continue to the next instruction. This does not appear until you've actually looked at and touched the correct component. Our knob is a little special in that you have to actually rotate your wrist as well. And yeah, once you're done with the instructions, it'll say you're complete. Now that you have an idea of what to expect, we'd like to invite a judge to come up here and actually try out a HoloLens. We will be streaming what you can see through the HoloLens on the screen so that our audience can follow along as well. And while we're setting that up and kind of going through that, we're also free at this point to take any questions.
Great presentation. I like the demo, and I mean, obviously really cool technology, and kudos to you guys for getting access to the technology too. I'm curious, can you, for those of us who aren't as familiar with the HoloLens, can you tell us how much of what you guys developed did you develop from scratch versus how much did you use, I don't know, the HoloLens API to put together?
I think a large portion of it involved existing features. So the Unity game engine contains the mixed reality feature toolkit, which is used to actually develop on the HoloLens. And within that, there are several libraries that are handling things like eye tracking, gesture tracking, hand tracking. I think our contribution to this project was figuring out an application, how to actually use these features. This technology is just so new that there aren't actually a lot of applications out there for HoloLens at the moment, which was actually one of our challenges. As you saw at the beginning, we weren't even sure where exactly to start. There were multiple directions we could have taken. So although a lot of the features we used did exist, combining them in a way that made sense and combining them into a project that was actually usable was a big part of our contribution.
When you were designing your application, were you thinking about, sorry, thanks. When you were designing your application, did you think about the user, the persona, who would be actually, doing this work? Like the type of person, their education level, their age, their dexterity. Did that figure into how you decided to lay this out?
That was also another challenge. I think the way that we envisioned this project going would be kind of taking place in the future where everyone is a little bit more familiar with augmented reality and the HoloLens. One of the big challenges we faced was that, prior to this project, we had never seen a HoloLens before. Most people have never seen a HoloLens before. So the more we worked on it, the more the disconnect grew between us as users and the average user. So I think when we were designing this project, we were imagining a future in which there are already CAD models available of Navy ships, machines. There are already people familiar with augmented reality. And from that basis of the idea of someone being familiar with the basics of a HoloLens, that's kind of where we started. We were assuming that they knew how to use the HoloLens and that they were familiar with augmented reality, but did not have any background beyond that on the specific system that they were using.
That said, a lot of it is intuitive. Like the buttons are made to look like normal buttons. There's instructions that pop up that you can just clear away as if it was a normal window or as if it was a physical button that you could press. So it's supposed to be somewhat beginner friendly. As opposed to some other, AR applications that might require some more expertise.
And you talked about verification at the beginning. How did that work through this process? Did you have established metrics that you needed to meet? How did you achieve those?
Sorry, could you repeat that last part?
Yeah, the metrics that you talked about in your verification, can you describe some of those things that you did to verify that this was exactly what you needed to do?
Yeah, so for example, like the hand tracking, we had a couple different ways of implementing that. We were looking at the absolute position of the hand in like the absolute world space. We were also looking at the relative position of the hand and specifically the fingers to the components on the board to make sure that you're actually touching them. So we use those two things to balance each other out. The eye tracking is something that I think that's one of the more inbuilt Unity functions, but getting that to work and including the highlighting with that was more of the challenge for us. And then the gesture tracking is also something that Unity has a lot of inbuilt functionality in, but there's also a lot of customizability to where you can deal with like specific things like rotating your wrist, but you can also add much more customizable things like specific hand or finger joint action, depending on whatever the needs of the component are.
Great, thank you. It's great. I love the roadmap too, that you guys had that listed out. That was great.
Thank you for teaching me how to fix a ship. Great job, guys. I just want to give a shout out to special thanks to Shelby for being brave and trying our demo. Thank you so much. All right, last but not least, our next presentation is by a team called So Far So Good. They're going to talk to you about their project GitHub Auditor, and their mentors and sponsors are the Xenon partners.
All right. Hi, everyone. We're your team So Far So Good, and our project name is called GitHub Auditor. I'm Chris. I'm the team lead.
I'm Thomas. I'm the team scribe.
I'm Kyle.
I'm Edward.
I'm Nico.
And our mentors are Jason and Donnie from Xenon.
All right, so GitHub is a website where millions of developers and companies maintain their code base. Currently, there are more than 4 million organizations and 200 million repositories created. And our sponsors, Xenon Partners, handles 10 companies with multiple orgs and thousands of repositories. The problem that our sponsors have is that as of now, there's no efficient way to audit multiple orgs and repos. This is due to security vulnerabilities being too spread out within the GitHub website. And that makes auditing a little bit more tedious and time-consuming than it should be.
Yeah. So our app will handle 4 security alerts,
The first one is two-factor authentication requirement, or 2FA. So this is a requirement at the organization level that requires that every member of the organization has 2FA enabled for their GitHub account. So if a user doesn't have 2FA enabled, then it's easier to compromise their account. And if their account's compromised, then the whole organization's code base is also compromised. The second alert is dependabot alerts. So this automatically scans the code in every repository and detects if a package dependency or a code dependency is out of date or has existing security vulnerabilities. The third alert is secret scanning alerts. So this automatically scans the code as well and detects exposed API keys or other private authentication keys. So if a third party were to gain access to one of these keys, they could steal the company's data, but also the company's customers' data. And obviously, this is a huge security risk. The last type of code alert, security alert, is code alerts. So this is similar to secret scanning alerts, except companies can define their own custom code scanning patterns that they think would also pose security risks. And so overall, the main goal of our app is to make auditing these 4 security risks as fast as possible and as easy as possible. And to do this, our app basically acts as the centralization of all 4 of these security risks for the organizations and repositories that a user owns.
All right, so now I will take you to a demo of our app. So you can see it's deployed at githubauditor.herokuapp.com. And so it takes me to the login page. So the first thing I'm going to do is log in with GitHub at this button. And I've set it up so that it treats me as a new user. So as a new user, you'll have to authorize the tool to gain admin access and access to your public and private repositories. And this is because this is really an admin level application, so it really needs access to those features. So I'm going to go ahead and click authorize. And let's see, fill my password. And so after I've logged in, it takes me to the docs page. So at the top here is the introduction to what this security dashboard does. If I scroll down, we can see the section for how it works, which we'll explain later. And then after that, we have code scan alerts as well as dependabot alerts. So those were explained by Nico, but this is just for any user who wants to see what those do. And then finally, there are instructions for how to view your audited organizations. So it's instructing me to click the organizations tab to see all the organizations I'm a part of. So I'm going to go ahead and do that. And you can see right away that I can see every single one of my organizations that I'm an admin of, as well as at a glance which ones have security flaws, such as two-factor authentication requirement, dependabot alerts, code scan alerts. And if I were to click on the filter button, I could choose to filter by lacking dependabot alerts and two-factor authentication. So for now, I'm going to go into test organization 1. And you can see once again that I'm able to view all of my repositories at a single glance for this organization. And once again, I can filter by dependabot alerts, for example. So I can see that, for example, my VS Code repository has one critical dependabot alert and several other dependabot alerts of different levels of security. So if I were to click on that, it would take me straight to the page on GitHub where I can see the more details. But as you can see, the main innovation is that we have all of these repositories viewable at a glance. And so I could see, if I wanted to, I could go in to see the code alerts, but really I'm interested at the high-level view that I would get here.
Okay, so now that you guys have seen the demo of our app, I'm going to go into some details on what actually happens when the user logs in for the first time. So to start off on the front-end side, which is built using React, after the user signs in via GitHub OAuth, it'll return to us a permanent access token, which we will then send to our Ruby on Rails application server on the back end. And then from here, two things will happen. First, we'll store that permanent access token into our PostgreSQL database, which I'll explain why later. And then two, it'll queue an asynchronous audit job on our Redis job queue. And the reason why we choose to process this asynchronously is so that the user will not have to wait in the login screen for our app to audit all their orgs and repositories. So once that audit job is placed into our job queue, there is a cluster of workers, which is essentially a distributed set of machines that are responsible for consuming tasks off our job queue. And so once a worker picks up a task, it'll make a bunch of requests using that permanent access token to GitHub's API, which is used to retrieve all this information about the users, repositories, and organizations, and then we'll audit them accordingly. And then once the audit's done, it'll store all that data back to our database. And to ensure that our data is strongly consistent with GitHub's, it'll also enable a feature called webhooks. So for example, if a new dependent bot alert is created, we'll want to update our database accordingly so that our dashboard is up to date with what GitHub is. And so when that alert is created, GitHub will send our Ruby on Rails server with a webhook payload, and it'll go through some logic and update the database accordingly. And in addition, every time there is a new alert that's created, it'll go through the whole asynchronous job workflow, except once a worker picks it up, instead of an audit job, it'll be to email all the relevant stakeholders of the newly created security vulnerability, and that is done through a third-party service called Mailgun.
So for the technical challenges of this project, so the first technical challenge that we faced was Ruby on Rails. So almost all of the team members had no experience with the backend framework. So from the start of the project to the end, we had to learn all the aspects of that, considering API development, but not only that, as well as like using Postgres and testing the APIs with Postman. After that would be GitHub OAuth. So when the user first logs on to the website, we want to make sure that they stay logged on. So once the successful request goes through, we make sure to store the token in the website. So that way, when the user relogs on, they don't have to relog in, and they'll be automatically logged in. After that, it would be Redis. So this consists of queued asynchronous jobs, as Chris said. And for this, so when a webhook is triggered or like an email notification is sent out, we wanted to make sure that Redis handled this. So we had to interact with the dashboard and make sure that everything executed correctly, and we had to learn that from scratch. And then after that, it would be system design. So we had trouble in the beginning determining whether we wanted to go with a monolith of a structure or separating it out into microservices. And we discussed this a lot and decided to go with microservices to allow with a greater separation of concerns. And I think this was very beneficial, and it helped with our development. So for the innovations of our project, so the first one is a centralized dashboard for security alerts. So all the information is available on GitHub. However, for a company like Xenon, which manages thousands of repositories, if like an API key is leaked, they're not going to know about it like right away. So using this dashboard, they can look at each individual organization and like look at each repository in each organization, and they can see, okay, this repository has an API key leaked. We need to get it taken care of. So it makes it very easy to see and make sure that nothing in the past can happen. Next one would be utilizing GitHub webhooks. So when the user refreshes the site, a webhook is triggered. And what this will do is this will update the databases that we have and make sure the data is stayed up to date. So that way, there's no out-of-date data on the website, and the user has always seen the most recent security concerns. The next one would be a regular email notification of a security alert. So like, for example, in the previous, for like, if an API key is pushed to GitHub, we want relevant parties, like our mentors, to be notified about it right away. So that way, like if this happens, they'll know and they'll be able to fix it within like a day or so. Whereas in the past, this has gone unnoticed because they just didn't know about it. And then a special thanks to our mentors, Jason and Donnie. Unfortunately, they couldn't be here today, but they were vital to this project, and they were extremely helpful throughout the process. And any questions?
Questions from our judges?
Great presentation, guys. And it's kind of similar to what I said earlier about, taking the monitoring perspective. I like that you guys had the classification of severity on the different things that you found. One thing that I would think of is really try to be end user centric and really think like if you're marking something as critical, you're moving into a position of thought leadership as a platform, right? So really making sure that you're putting the criticality right in front of your user. I don't know if you have any thoughts in the future on improving that or making it a little bit more, maybe not directly actionable, but again, taking a thought leadership perspective and trying to promote that.
Yeah, so the way we classify like the dependent alerts in the demo that you saw is actually not through our own means, it's actually just via GitHub. So when GitHub's dependent alerts feature actually gets created, they classify the severity themselves from a list of enums, which is low, medium, high, or critical. And then whenever we retrieve the dependent alerts via GitHub's API, it returns to us like the severity level. So that's just how we classify it right now. We don't use our own classification system or anything.
Yeah, makes sense.
Yeah, great project. I just had one question. I really liked her UX design. I was thinking for more of a scaling, what would it look like for a larger organization? And how would I search through that and get the relevant data?
Yeah, so obviously in the demo we had about only 10 different or 8 repositories, but we included the search bar at the top for repositories and organizations so that in the event that Xenon uses this where they have to manage tens of thousands of organizations or repositories, they can just simply use the filters to just filter for certain repositories that have pending dependent alerts or secret scan or code scan alerts, or they can also use the search tab as well to search for the name of the repository that they're interested in looking at.
And then does this system, will it generate a report? Is that what gets sent out? Or
It's not really supposed to be generated as a report. It's mostly just supposed to be sort of an insight dashboard. And then you yourself as the security expert are supposed to draw insights from it and decide how to proceed. But as I mentioned earlier, every time a new security vulnerability is created, we notify the relevant stakeholders. If Tom, you want to show them a sample email that was sent via Mailgun. So in another repository, I created a test AWS account and committed an access token, and then this is the email that was sent to me after GitHub detected that the API key was committed in the code.
Okay, great. Thank you. Really nice.
Okay, thank you so much for all that. Let's give a big round of applause to all the students and all the great work they did and all the sponsors. That concludes our the CS Capstone part of this in terms of the presentations. We're now going to have a coffee break for about a half an hour. We have lots of good snacks and coffee for you back there. Maybe stretch your legs a bit, but I really would love it if you could come back at 4:30. All my teams should be back at 4:30, and we will announce the Capstone Awards for second and third at that point. And I just want to take a moment and introduce my chair, the chair of computer science, Dr. Tevik Bultan, and he's just going to say a few words about what's coming up later this afternoon.
Thank you. I just want to say I'm the proud chair of the computer science department, and the reason I'm proud is because of the amazing projects our students do, amazing students. I want to thank Chandra and John Wan and our TA, amazing job. The judges, the sponsor teams, and the mentors. It was really amazing again, and I say if you want to see the future of the computing, the best thing you can do is come to the Capstone presentations, and you can see where the discipline is going. So it was the case again. I want to point out that the discipline is becoming very multidisciplinary, right? You can see biological, applications, medicine applications. I mean, everything we are doing is now involving another discipline. So in that trend, what we did this time, invited 3 of our affiliate faculty. They are faculty in other departments, but they have affiliate appointments in CS, and they are going to give 3 short talks after the coffee break we have, after the award presentations. And they are Jennifer Jacobs, Assistant Professor in Media Arts and Technology, Katie Beal, Associate Professor in Electrical and Computer Engineering, and Nina Miolane, Assistant Professor at Electrical and Computer Engineering. And some of the topics they'll talk about, for example, expressive computation, integrating programming and physical making, connections between reinforcement learning algorithms and classical dynamic theory in robot control, and geometric learning for biomedical shape analysis, which is, I think, directly related to one of the projects we just listened to. So I hope you stay for that. We are going to have another break after that, a reception. So I hope you stay till the end of the program. And thanks again to all the students that did a great job today. Thank you.
All right, can I get your attention, please? Or can I have the mic here, please? Thank you. All right, can I get your attention, please? Come on back. This is the time we've all been waiting for. This is the hardest part of the whole thing, in my opinion. From my perspective, I think I have 10 amazing winners, but we have to pick first, second, and third. So we're going to first announce the third place, and then second place, and then first place. When we do each one, I'd like the team to come up. We're going to take a quick picture together. But before I do that, I just want to give a shout out to Mason Quarry. Can you please stand? Right? Right. An amazing TA, an amazing TA. I couldn't have done it without him, and I'm super grateful. It's been a wonderful partnership, and thank you very much for all the work you put in. All right, so without further ado, we're going to go to third place. This was really hard, really. We debated and debated, and it was like we could be here till next week. Third place, Nomads. Navy Operational Machine Auditing Development Suite. And there's money behind this, so they're going to be celebrating this week. Now, second place goes to BCare, Virtual Reality Therapy. Congratulations. Thank you. Great job. Congratulations. And first place goes to Smart Grid, Pina Colada. Come on up. As they come up, special shout out again to our judges. You guys were amazing. Thank you so much for participating. We couldn't have done it without you. And your questions were amazing, really great. Thank you again. Let's thank our judges. that's it. We're going to take a break. No, actually, we're just gonna start off with our next session. Professor Bolton's going to introduce our multidisciplinary faculty research talks. I just want to say thank you again for all of you for being here, and I really appreciate it, and great job today, teams.
Well, I think we are a little bit ahead of schedule, but we'll just start the talks. And so first, I want to say again, this was great presentation for the Capstone students. Good job. And I think they should stay and listen to the talks because there's some research, very exciting research here that you are going to hear. So one thing that I want to say that the Capstone projects are always like predictive of where the computer science is going. And I think the projects we have seen are definitely showing that the computer science research is becoming very multidisciplinary. So, and one of the things as the computer science department that we have focused on recently is increasing our multidisciplinary research and multidisciplinary focus. And one side effect of that has been actually the number of affiliate faculty in our department has increased significantly. So I think now we have more than 10 affiliate faculty, and they are doing all outstanding research that involves computing, but also other areas. So and I think that's going to be the future of computer science, more and more interdisciplinary research. So it was with the CS Summit coming back, we thought this is a good opportunity to actually invite some of our affiliate faculty to talk about their research. And we will have 3 short talks following the Capstone model, 3 fast talks. And so the first one is going to be on by Jennifer Jacobs. She's an assistant professor at Media Arts and Technology, and Jennifer is going to talk about expressive computation, integrating programming and physical making. I want to just give a little bit of her bio information. She's an assistant professor at the Media Arts and Technology program, which is actually closely affiliated with computer science. We have faculty who are in computer science department and have, collaborated with the Media Arts and Technology program, and vice versa, like Jennifer. Jennifer, at UCSB, she directs the Expressive Computation Lab, which investigates ways to support expressive computer-aided design, art, craft, and manufacturing by developing new computational tools, abstractions, and systems that integrate emerging forms of computational creation and digital fabrication with traditional materials, manual control, and nonlinear design practices. Prior to joining to UCSB, Jennifer received her PhD from MIT and was a postdoctoral fellow at the Brown Institute of Media Innovation within the Department of Computer Science at Stanford University. She also received MFA and BFA from Hunter College and the University of Oregon, respectively. Her research has been presented at leading human-computer interaction research venues and journals, and most prominently at the flagship ACM conference on human-computer and digital systems, CHI, where she received 2 Best Paper awards and 1 Best Paper Honorable Mention Award in the past 4 years, which is just remarkable, by the way, if you know the area. And as primary investigator, she has received 2 research grants in 2020 and 2021 from NSF, Division of Information and Intelligence Systems in Computational Fabrication for Manufacturing and Commercial Craft. So I'll now pass the mic to Jennifer to talk about her research on expressive computation, integrating programming and physical making. Thanks, Jennifer.
Thank you for the introduction, Tefik. Let me just get my computer working. All right. Great. So it's such a pleasure to be here. Thanks everyone for coming. It's wonderful to be able to speak in front of a CS audience, and so much of my work fits in that space. Today I'll be talking about my research in integrating computation with manual and physical production. There are two big ideas that this talk and my work revolves around. First, I argue extensively through multiple forms that despite current trends in automation, computational and manual forms of production aren't mutually exclusive spaces. And then connected to this idea, I'm going to argue that by understanding traditional forms of production, traditional making practices, we can better inform our development of future technologies. So building an understanding of traditional practice can lead to innovation in emerging technologies. So before diving into some of the work behind these ideas, I want to briefly touch on the context in which I work. At UCSB, I direct the Expressive Computation Lab, which Tefik mentioned, and it's an interdisciplinary department that focuses on a lot of different research in different dimensions. So many students in my lab focus on building software tools for computational authoring. This is work in progress by actually a CS master's student, Sonia Hashem. And the tool Sonia is building is aimed at enabling motion graphics designers to use hand-drawn geometry to specify procedural functions that create animation. Much of the work that we do in ECL requires understanding professional practice, and Sonia's work is evident of that, so she based the design of AIMS on interviews that she conducted with professional motion graphic designers. ECL is also concerned with the physical as well as the digital, and we conduct research in novel materials and workflows for fabrication. This is work from doctoral candidate Meir Hirsch's dissertation, where Meir has developed a 3D printing method using sodium acetate crystallization. And these real-time videos demonstrate how Meir has refined this method to support 3D printing at a rate that's much faster and in forms not feasible with through traditional additive fabrication. While our focus in ECL is largely on researching novel technologies and tools, many of our students are also artists and they create artwork. Here you can see a dynamic soft robotic sculpture created by the PhD student Sam Bourgault. And creating works of art and design is important in our group because it provides students with an opportunity to examine the affordances of computational media by making artifacts. And then finally, we also engage with outreach in local communities. These images are from a recent workshop led by PhD student Ashley DeValle, where she taught 60 middle school students how to use computer programming as a means to create designs for computationally controlled plotters. And these outreach activities are a really important element of our work in that they enable us to build partnerships with experts and community groups that foster future research opportunities. And I'll touch on partnerships and their role in our lab later on. So the work of ECL is super varied, but our work is unified by this emphasis on computation as a medium for making things. Computation increasingly shapes both how and what we make, and different computing paradigms, both established and emerging, offer creators new ways to think and new spaces to make in. Expression in any form of computational paradigm is mediated by the design and structure of a computational tool. And by that, I mean any tool that enables the creation of work through a series of rules, models, or instructions that can be maintained or executed by a computer. So computational tools can encompass anything from symbolic programming environments and parametric CAD to automated algorithmic filters or even CNC machines. So like any tool, computational tools extend and constrain the capabilities of different people based on how they're implemented. For the example, the creative coding language processing lets artists create dynamic work, but it also requires them to work through a symbolic description of the work itself in the form of code. The process of building and designing computational tools is challenging. Part of this challenge is because of the nature of human production. Different people make work in vastly different ways, and the key properties of different domain-specific forms of production are really difficult to define and often complex and steeped in tradition. It's also difficult to build computational tools because computational platforms change quickly and often. And so, as a result, new computational platforms are regularly emerging as existing platforms are rendered obsolete or reshaped fundamentally. And then finally, it's difficult to build computational tools because computation itself is a fundamentally brittle medium, requiring the correctness of many low-level elements to function. So this structure can limit the adoption of domain-specific interfaces and interaction strategies, and also often encourages developers and designers to build tools as standalone siloed packages. So I hope I've convinced you why this space is hard. Let's take a look at some of the opportunities that we try to explore in our work. The creative opportunities of computation as a medium, contrasted with the restrictions and challenges of existing computational tools, suggest the need for new methods to inform computational tool design and implementation. So the objective of the work we do is really twofold. First, we try to support creators in using the opportunities of computation in powerful, productive, and expressive forms. And equal measure, we seek to understand how knowledge from established making traditions can lead to new groundbreaking computational technologies. We approach this space through systems engineering by engineering complex working interactive systems that let us test specific hypotheses on how different computational representations and technological interfaces can enable creators to integrate core elements of computational creation with practices from manual and physical domains. So this has meant working with people ranging from oil painters to low-volume manufacturing companies to production craftspeople, but it's also included working with people who rely on digital tools but don't program, like illustrators. And a lot of our work focuses on finding alignments between computation and specific domains of manual or physical production, and then testing tools that embody qualities of both spaces. So, to look at this a little bit more specifically, let's look at two research avenues that directly address this approach. First, I'm going to discuss in detail some work I've done integrating manual creation with computer programming. And then I'm going to talk a little bit about some current and future work we're doing in the space of computational fabrication and aligning it with traditional forms of craft. So programming, as I mentioned, is a really powerful tool for creation, but although the applications of code have broadened substantially, actual approaches to writing code are really narrow. And to kind of look at some of the specific challenges, people in my lab, including myself, have conducted interviews, in particular with visual artists and designers, that are focused on understanding how programming supports or hinders specific workflows. And one common theme from these interviews, although I'm summarizing a lot of work, is the importance that manual artists and designers place on a direct connection between their hands and their work, either in the form of manual drawing or direct manipulation. So a question that came out of this observation was, how can we build programming environments that support the integration of programming and creation by hand? And in this case, we're focusing on drawing by hand. And one of the things we looked at when thinking about this work was, what do artists who use programming but produce really expressive manual appearing work, how do they approach this work? So we talked to and observed people in this field, and a prominent theme was that individuals often create their own software tools that let them integrate working by hand with computational output. So this is a sample of the artwork by the artist Eric Natsky, where Eric has developed custom software that lets him draw freely with a digital stylus, while the software modifies the color and quality of his strokes by referencing different input data. So this theme, this insight led to this system that's kind of ongoing in the lab, Dynamic Brushes, which is an environment for personal drawing tool creation that enables manual artists to create ad hoc procedural tools that transform manual drawing input. The system interface is divided between a pressure-sensitive tablet and stylus and a desktop or laptop monitor, and the artist uses the tablet to author artwork and with selected drawing behaviors they've defined, and they use the desktop interface to author artwork drawing behaviors with a visual programming environment where they can drag out components. Programming in Dynamic Brushes is structured around the creation of brushes, which are interactive drawing objects that respond to manual input from the artist. And each brush object has properties that define the style and geometric transformation of its strokes. So the programming model is centered around, first and foremost, property mappings, which are declarative mappings between input data and brush properties. And the primary form of input data is the stylus, but mappings can also use generators as input, which are data types that produce a sequence of values corresponding to a given function, like modulation with a sine wave. Let's see. There we go. Lost my notes. Mappings are organized within states, which are collections of property mappings that hold true when the state is active. And then event-driven transitions enable state change. And transitions can occur on a variety of triggers that relate to manual drawing, like stylus events, for example. And then individual actions or transitions can contain actions, which are discrete methods that are called once the transition occurs. And I'll touch on this more shortly. So the addition of generators to dynamic brushes enables conventional drawing brushes to be converted into unconventional ones, like a brush that can modulate the scale with a square wave generator, creating an undulating pattern. So this approach is really important because it lets simple programs translate to different drawing tools with diverse outcomes that are still determined largely based on the paths that someone takes with their stylus. One of the most powerful aspects of programming is that it can be used to perform multiple actions simultaneously, leading to the production of intricate visual output. And dynamic brushes enable similar effects by using one brush to generate instances of new brushes. And this is facilitated through the spawn action, which is a method that enables a brush to generate a set number of instances of any other behavior, including its own. So spawning enables artists to use automated, timer-driven behaviors to augment manual strokes. So for example, this drip brush. One of the things I want to touch on with dynamic brushes is that it is a programming language, and it's subject to many of the same challenges that artists encounter when they're using any other programming language. It happens to be a visual language, which can reduce syntax errors, but it still presents some of the same challenges that other programmers face, namely understanding debugging and connections between code and output. So we've built on this system to try to understand how can we help visual artists understand their programs in domain-specific languages. And our main approach here is to link and visualize program parameters and state with the artwork. So additional research we've done in this space involved building a custom inspection and debugging environment for dynamic brushes, where we link program parameters and state to output on the drawing canvas. And dynamic, let's move ahead. So one of the key features of this debugging environment is that we created visual inspectors that lie on top of artwork and show otherwise invisible parameters like stylus input or brush properties while the artists are drawing. And this is enabled to support artists in reasoning about their drawing while they're actually working. We also explored this idea of direct selection inspection, where artists can touch any element of the artwork and then jump to the program state that corresponds to when that point was drawn and what element of the code generated that. And then we also added the ability to loop through past input so artists can focus on exploring variations in their code while not having to actually create manual input. So this is ongoing work. I won't touch on it all, but wanted to give some examples of this project. All right, skip ahead a little bit for the sake of time. So the dynamic brush work is one example of, kind of coming back to my key takeaways, of the ways in which computational and manual forms of creation are not mutually exclusive. Specifically, this work shows how tools that integrate computational and manual making can dramatically expand the expressive potentials of computers by preserving manual skills. Now I want to jump to the second claim I made really quickly. But this idea that we can better inform the design of innovative and impactful computational technologies by understanding traditional makers. And the key area we're looking at this idea in is the space of computational fabrication, which builds on some of the ideas I just presented, but where you take create a design that is generated by a computer program, but rather than stopping at the digital point, you use digital fabrication, at least partially, to produce a physical artifact based on that program design. And computational fabrication is interesting because although it's primarily been explored in engineering research and industrial architecture, it's also increasingly relevant to other creative communities, especially manual craft production. So we now have digital fabrication machines that can produce artifacts in traditional craft materials. So one of the kind of opportunities we see in this space is as we see more alignment between computational fabrication and craft materials, there's an opportunity to think about ways of broadening participation in computational production by developing new workflows for computational fabrication that support traditional craftspeople. So some of the work we're doing in this space right now builds on this idea by focusing on expanding a particular type of craft production, rural craft production, through integrating ceramics work and computational fabrication. This is active research that's done in collaboration with researchers at the University of New Mexico and is currently supported by a National Science Foundation Future of Work at the Human Technology Frontier grant. So I'll just touch a little bit on kind of the key ideas of this work. Our goals in creating this work are threefold. First, we're trying to identify opportunities for integrating traditional ceramic craft and computational fabrication together. Second, we're trying to actually build new computational fabrication technologies that are inspired and informed by traditional ceramic craft practice. And three, we're focusing on ways to actually directly support rural craft businesses through new forms of technology production. Some of the images on the side are work that's actually being done by my students in exploring computational fabrication with ceramics in our lab, which some of them are here today. Hi, guys. The project has been underway for about 6 months. Here's some of the work we've done so far. We've conducted interviews with master ceramics craftspeople, both in California and New Mexico. And we focused in these interviews on understanding how different approaches to manual ceramics practice actually align with or conflict with the affordances of computational fabrication. In tandem with these interviews and informed by them, we've looked at the ways in which we can actually apply emerging technologies and techniques like clay 3D printers and robotic fabrication to the production of ceramics artifacts in our lab. And this process, while very early in development, has revealed critical insights for how computational fabrication of ceramics is different from other forms of additive fabrication. Both of these objectives are leading up to our third component, which is the last slide I'm presenting, where we're focusing on using craft residencies as an HCI research paradigm to support the investigation of new computational fabrication technologies through co-production. So this work is modeled after some of our past collaborations and workshops, but we're actually conducting it at a much larger scale where we're hosting local ceramics craftspeople in our lab for a period of 3 months each as technological collaborators in this work. We've currently completed the first residency call and are in the process of selecting candidates to begin work this summer, so we're super excited, also a little nervous. And in general, this is work that really will shape the work we're doing going forward and thinking about how we can build from partnerships to develop new types of technologies for making. So with that, I will wrap up. Now I have a lot of extra slides. I just want to say thanks for attending the talk, and also a huge acknowledgement to all the people who've collaborated with me on this work. I think I only went 2 minutes over, so thanks so much. We have some time for questions. Okay.
Hey, is it on? Oh, okay. So thank you very much for the talk. And I wanted to, we have some time for questions. I have a question, but I wanted to first let audience, if there's any questions from the audience. Yep. Can we hear it?
Hi, so you mentioned debugging software as part of the dynamic brush. Do you mind elaborating on that? Because that's super cool. I'm wondering how artists would debug in real time.
Yeah, maybe I can go back to some of that. So it was a really large-scale process, and if you're curious, happy to talk more afterwards and also check out the paper. But in general, this is an example of why systems research is so compelling to me. We first built a programming language, which enabled us to investigate approaches to designing domain-specific primitives and development interfaces. But that also led to us having the opportunity to now explore different approaches for understanding programming behavior in that domain-specific context. And so really the approach for the debugging environment for demystified dynamic brushes, which is what we called it in the paper, was centered on the approach we saw where artists, when they were using the system, were trying to understand what was happening in their programs, not by looking at the code, the visual programming language, but instead by looking at the drawing output. And so we tried to think about, one, how can we provide some information for what's taking place in the drawing output, especially when you run into errors where conceivably it looks like nothing is being drawn on the screen, which is an issue that all programmers experience in some case. And two, because we see using symbolic programming as a really powerful opportunity for visual artists, how can we help them make links from what's happening to the programming in the drawing environment back to the symbolic programming environment? And so a lot of our functionality, like I described, is things that are purely designed to function on the drawing environment. We also, I didn't talk about this in the talk, we also developed a more conventional form of stepping and breakpoints in the symbolic programming environment that enables artists to engage in more low-level debugging and testing of their programs in a way that's really necessary as the programs themselves become more sophisticated. So in general, we think about this as like a scaffolding approach, where how can you start in one space and then move to a less familiar space? But hopefully that gives you a little more insight.
Yeah, I had a question, actually, maybe very high level, but
Yeah.
just wanted to get your opinion on it. So when you get the artists involved and this programming environment that you provide, does it generalize from one medium to another one? So I mean, I assume from painting to maybe sculpturing, but if you go to music, is it like abstractions, do they generalize?
Yeah, so it's a great question. We are actively exploring this through other systems. I don't think the sound is playing here, but this is work by one of my students in the audience, Sam Bourgault, where she's actually looked at building from some of, mostly her ideas, but some of these ideas of supporting computational production through, but preserving manual input, but in the space of multimodal production, where you can do animations, but also audio output. And I don't think I'm plugged into audio, but there's sound being generated here. And so the actual primitives, the representations are different. We have to develop them in different ways. But the general approach, I would say the thing that generalizes is more our design approach for how we try to inform these primitives, how we try to test them, and how we try to judge the success of the system itself. We're actually also exploring kind of a similar domain in the space of dynamic computer-aided machining, or the workflows people use to program CNC machines, because there's a similar parallel between wanting manual control but also wanting automation. But because you're dealing with atoms rather than bits in that space, you start to run into some new challenges as well.
Well, thank you very much.
Thank you.
Maybe, okay. So the next speaker is going to be Katie Beal. Maybe, Katie, do you want to connect the, or if you, actually we have a connection. If we can, let's see. I think I have it. Yeah, I was just wanted to. All right, so this is one, and the connector should be there. Yeah, while I'm introducing you.
Thank you.
Yeah, our next speaker is Katie Beal, and she's an associate professor at in Electrical and Computer Engineering department. Katie received her BS and MS and PhD degrees from MIT, and her research is dynamic systems and control, with particular interest in modeling and control techniques to deal with the inherent challenges of actually underrectification, underrectification and stochasticity that characterize the bio-inspired robot locomotion and manipulation in real-world environments. And she received funding from DARPA's M3 program, DARPA Robotics Challenge, the Army Institute for Collaborative Biotechnologies, Robotics, NSF Career Award in 2013, Hellman Foundation, and Alfred Sloan Research Fellowship in Neuroscience. Katie has worked on a wide range of research topics in the control of dynamic systems, including magnetic bearing control, flapping wing microrobotics, and noise cancellation for aircraft, and vibration isolation for gravity wave detection. And this is the coolest ending. And she was once a professional gambler at MIT Blackjack team. Thanks, Katie, for coming and visiting us.
Yes. Oh my gosh, thank you so much for inviting me. I'm glad everyone has come, and I apologize. I have just walked in from teaching. My class just ended about 15 minutes ago, the last class of the quarter. So thanks to everyone for toughing it out these past 2 years, students and faculty alike. All right, so my talk is, it's not going to be so much video in this, and it's got a long title, but the real focus is on robot control, which is what I do. And again, my name is Katie Bill, but it sounds different than it looks. It is really just like dollar bill or the Bill of Rights. So, locomotion control. Everyone has seen videos of Boston Dynamics impressive robots, and so I won't show them again here. Hopefully you've seen them, right? And I think what a lot of people ask themselves or think to themselves when they see these videos is, oh, we have proven there are successes in coming up with control via machine learning, right? But I'm already crossing this out because really, from what I know of the people that work at Boston Dynamics, that is not what they're doing. It is very much model-based design. So why is this, right? Anecdotally, especially in animations, we see lots of successes for machine learning. But if NASA is sending a rover to Mars, those kind of things, right? There are no real assurances that we fully understand what's going on. So this talk kind of goes off in a, it's a connections talk into a direction thinking about dynamics from kind of a classical point of view and whether there are any lessons that then can also be used in machine learning. So more specifically than robot locomotion or robot control, I'm thinking about robot locomotion control and the challenges there I broadly put into 3 categories. So robustness really means that you want to be able to deal with unknown variability, slipping on the banana peel, or the guy at Boston Dynamics that pokes you with the stick or gives you a kick, and you didn't expect it, but you have to recover. But we've all been watching the Olympics, right? And sometimes you have perfect knowledge about the environment, but it's still a hard thing to do. So pick your favorite sport. A running back in American football, a soccer player trying to, hit some kind of goal, gymnastics, skating, whatever it is. It's hard, even if you know what's coming up. And then you need to be as energetically efficient as possible. And I like the kangaroo, because apparently kangaroos can sniff out the moisture in the air, and they can travel very efficiently for, very long distances to get to the next grassy pasture because of the tendons in their legs. So, if we have these 3 challenges, how do we address them? The first step is to try to quantify them. So we look for a scorecard, somehow, how robust is this robot versus another? A score for the Olympics. How good is this gymnast versus another? How much energy do I use is probably the easiest one to quantify. And then there are always going to be trade-offs. And so this is the name of the game, and it's the perfect structure to put it into machine learning, right? We've got a number. If we can somehow combine those numbers, perfect. We can at least find locally optimal things, and that's the direction people are going in. In this particular talk, I'm going to focus mostly on this robustness challenge. They're all interesting. And we'll talk about later what I mean by robustness. But basically, let's try not to fall down as a robot. So, quick outline of the whole talk. I'm going to talk a little bit about chaos, and then model-based control policies, and finally a little bit about machine learning. And this is all pretty high level. So, chaos. So, this guy, Edward Norton Lorenz, he was a meteorologist, a mathematician, a professor at MIT, and he's famous for something. Does anyone know? The Lorenz. What do you associate with Lorenz? Anybody? Yeah, tractors, and what else did you say? Sort of this idea, when you think about chaos in general, this idea somehow a butterfly is flapping its wings and we cannot predict the weather, right? But somehow things go crazy, and that's what chaos means. Well, there's actually something called the Lorenz butterfly. It's a very simple system in 3 dimensions. It's hard to visualize here. I could do a little video, but you can get the idea that if you start with some initial condition, you'll follow this. You have to picture this being kind of this split shape. So it's a 3D space, but somehow the flow is converging to like a 2-dimensional surface within the 3D space. But it's not actually a 2-dimensional surface. It's got these weird stripes too. It's very sensitive to initial conditions. This is the idea of the weather, right? It's hard to predict the weather past a certain point. We're getting better, but it's still hard. But there's still this structure. So chaos is not just particles of gas, and they're in a box, and I don't know where they are, and they could be anywhere. Chaos means something a little bit different, and it's the fact that it has this structure that makes it interesting. Interesting to me, because I'm thinking about high-dimensional problems where the curse of dimensionality becomes important, and where I'm thinking, hey, is there something that can happen with the dynamics that reduces dimensionality of large problems in a clever way, the way chaos does? So still kind of messy, but structured. And that's what the rest of this is about. So there's something known as a compass gate walker, which is a simple walking model. And here, by compass, I don't mean north and south. I mean this thing that's going to draw a circle for you, right? The compass gate walker just has 2 links with point feet. The simplest version has no actuation at all. It's completely passive. If I put it on a gentle slope, it will walk with the right initial conditions forever without falling down. A cool model because it's very simple, similar to the way humans are walking a lot of the time. You have a foot on the ground, and even without actuating your foot, or even with just a tiny amount of actuation on flat ground, you can have stable limit cycles. So this is this good, efficient thing for us. But there's something interesting about the way that this simple system walks down a gentle slope. If the slope is not too steep, it falls into what we call a period 1 gate. It's a limit cycle where every step is like every other step. And I'm trying to plot states over time. So 1 angle for the left foot, 1 for the right foot, and there are 2 velocities, 2 different values, or 4 different values altogether, 2 positions and 2 velocities over time. Each one converges to some same value. If I take a snapshot, like a picture, every time the foot hits the ground. This is an idea of something called a Poincaré analysis, when instead of looking at the dynamics over all time, you wait for the dynamics flowing over time to hit some particular event. And the event I'm looking at is when a foot hits the ground. I take a snapshot. What was the angle of each leg? What was the angular velocity? And actually, taking the snapshot, I don't even have to keep track of the angle of each leg, just the angle in between, because there's a constraint that both feet are on the ground. So instead of having 2 positions and 2 velocities, I have 1 less dimension already, 3 dimensions. And this is this messy plot, but basically I start somewhere, and somehow step after step, discretely, it zooms in to this 1 point, a period 1 gate. Now, if I make the slope a little bit steeper, I have these other details here on these other plots that aren't important, you'll get a period 2 gate, where every other gate, now I'm starting, instead of away from the cycle, I'm starting exactly on the cycle. And you can't see the other point there, but I keep jumping from one to the other, whether I'm thinking about 1 state, the 2nd state, the 3rd state, or the 4th state. If I map what happens from 1 step to the next, it's just tick-tock, tick-tock, tick-tock. A slightly longer, slightly shorter step. As you get even steeper, you now see a period 4 gate. 1, 2, 3, 4, 1, 2, 3, 4. Again, this is totally passive, just starting with the right initial conditions on a gentle slope with the right mass properties. And you can kind of see where this is leading. This is something known as period doubling bifurcations. Somehow I'm adding energy to the system, and as things get steeper and steeper, instead of period 4, now it's period 8, and then period 16, and then there's this weird structure appearing, but instead of just doubling forever, eventually it's as if the doubling happens so fast that it hits this wall, where it really does not repeat anymore at all. And it's not just numerically that you can't find the repetition. You can do some simple toy analysis of like thinking what happens from 1 step to the next, and show that, hey, it may not ever be falling down, but it's not that it repeats after 10 million steps. It really just never repeats. And this is what chaos is. So each step is falling in this weird structure in this space. And I never repeat what I see, so it's unpredictable here to predict long-term exactly which point I'll have, but the set of points does not fill out that entire 3D space. Okay, so there's structure, there's sensitivity to initial conditions. And I had some more videos, doesn't really matter, but if you look carefully, this is similar to the past plot here, kind of rotated. If you were to zoom in on this, it's not even like a 1D set. It's like, I don't know, like a city map or something, where there's places that are dense, places that are not as dense. There's a lot of structure, almost like a fractal nature to it, as you zoom in more and more. Okay, so if we think about this, and we try to think about what is the dimensionality of that set of points, there's actually a mathematical way to do it. So stay with me here, and let's think about it, because it's not necessarily 1D and it's not necessarily 2D. It could be something in between. there is such a thing as a fractional dimensional shape or structure. And here's an example coming up soon, but just to start and think about, make sure we know what dimensionality is. One example I like to use, so okay, sure, we've got a 1D set, 2D, 3D. If I try to cut this 1D set in half, you know, instead of having one line, I've got two. But if I had a grid, instead of 2 points, I have 4. If I have a box, instead of 2 points, I have 8. 2 cubed, right? So, you know, why do I care about this? Well, if I'm using numerical methods in machine learning, one way to approach analyzing dynamics is by discretizing them and looking at it numerically. But this breaks down because of the curse of dimensionality. Because now if I have even the simple walker with the 2 angles and 2 velocities, this is 4-dimensional. As I try to increase the resolution, it becomes incomprehensible how much it would be required to keep track of states, like on a discrete, like using a computer on a discrete time basis, right? So the way I like to think about the dimensionality is like, let's say you're Amazon and you want to decide how many distribution sites do I need, right? Say you're thinking, well, I really don't want anyone to have to travel more than 1 mile, okay? If everybody lives on one street, even if the street, you know, is turning, you know, to first approximation, it's like, fine, okay, I have 100 miles, I need 100 distribution sites, right. But the scaling, you know, now if I'm going to cut that in half a mile, fine, then it goes to 200. But if everybody's in a neighborhood stretched out in 2D space, and I go from 1 mile to a half a mile for the people to travel, things go up by a factor of 4. You can see where this goes, right? It's just, as the dimension, we like systems that have low dimensionality if we're going to analyze them numerically. And for this shape called like a Coke snowflake, or sometimes I think people pronounce this cock snowflake, you take this line and then you take the middle segment and poke out like this and repeat, you get a snowflake shape. This is neither a one-dimensional shape, just the border trajectory for this fractal structure, nor a 2D shape. It's something in between. If we were to think about trying to put that distribution site that Amazon wants in some point along this shape, and then be able to track, okay, this one distribution site, he covers all these guys within a certain radius, and then you repeat this again and again, As you're changing that radius, it doesn't scale like a straight line. It doesn't scale like a 2D space. It's in between, the way that it scales. And this is exactly what is meant by a fractional dimensionality. This is exactly what's meant by a dimensionality at all. So you can do a log-log plot and see how that scaling goes. For this shape, it's around 1.26. It's a 1.26 dimensional thing. Checking myself on time. The compass gate walker, when you do a similar analysis, you can look at those points on a discrete time basis, and it ends up being around 1.25. So you guys are with me now? It's just kind of this nerdy math stuff. But if I were somehow trying to keep track of the points, I can go back to the log-log plot. This is just kind of showing as my radius is changing, you know, as the radius is getting larger, how many fewer points do I need? Or as the radius is getting smaller, how many more points do I need? The reason that this other plot doesn't look quite the same is because I'm doing this numerically. So in the limit, I will always have 1 point. So this can never go below 1. And then depending how many points I choose to take, and here it looks like I took 10 to the 5th, I will never have more than that number of points because it's a numerical approximation. But there's a region where you can kind of capture what that linear scaling is. Okay, so that's chaos. Now back to model-based control policies, which is something my group had done basically exclusively since I got here until just maybe 3 years ago or so. And one of the simple models that people use is this point foot walker that is under-actuated. So it does not have an angle that can apply torque where it meets the ground. And this is a lot of people model primarily the forward kind of the frontal plane of stability versus side to side as a first step for a system. So here we have 5 links. So I have 5 angles, and I track their velocities. This is 10 states. This actually becomes a big state space if we try to think numerically about tracking all of the states that we could possibly visit. And what I really want to do is think about some way, brute force, to consider this to be like a Markov decision process, that I track who's going from where to where in this state space. So my fingers are crossed that I will see structure in the larger 10-dimensional space. And again, we were talking about robustness. So how am I quantifying robustness? It is just how many steps to take on average between falling down. We call this like a mean first passage time, similar to physicists. And again, the motivation is to avoid the curse of dimensionality in trying to analyze long-term dynamics for a very nonlinear, messy system by hoping that there's a reduction in dimensionality. So we build meshes because of the reduction in dimensionality. That's where I'm going. So the real goal, there's this word metastable. There are these advertisements about diamond rings, and they say like, you know, a diamond is forever. And well, you know, it is for a long time, but it is not the most stable form for a diamond. If you wait long enough, it is going to turn to graphite. You just have to wait a very long time, or magnetic tape. It is a metastable thing. This is all that we hope for walking. Of course, things will fall down. The robot might rust away, but we can be in a local minimum with good performance for long periods of time before reaching a more global, fallen down, more stable state. And I should wrap up now. I will speed through the rest of this because I think you guys get the gist of things. We have a metric for model-based control policies. We tend to see with machine learning now that when we find policies as well, I'm going to skip through slides to wrap up right now, but both the model-based controllers, where we have a set of low-level controllers we switch between, see these structures, these fractional dimensional structures that allow us to kind of model which state's going to which and reason about long-term dynamics. And for machine learning, we have seen as well, when we push systems around and we use deep learning on some of these, you know, Mujoko-type models, that even when the state space is really huge, if you think about it, the only way the machine learning can ever find a control policy is not because it can sample across a 30-dimensional or 60-dimensional space. There is no way to do this. So if it comes up with something that looks anecdotally interesting, our thought is there must be a trick. And probably the hyperparameters, all of this is exactly being tuned to find these tricks without thinking about it in that way. One plausible trick is you want to keep encouraging revisiting the same subset of space, which is what we do. And I think I'm just going to wrap things up here. This is basically what we've seen, both not just for the model-based control, but for deep learning as well. And I've got a doctoral student who is going to be presenting on this on Monday, Sean Gillen. I should go to the very last so you can see blah, blah, blah. We've seen like some examples, blah, blah, blah. But I haven't shown Sean's work. I'll just leave it to say that we use that dimensionality as part of the reward in machine learning. We look at the trade-off, not just robustness and agility and energy efficiency, but like, do we get better performance if we try to encourage there to be a low dimensionality? And is this some kind of route toward having brute force ways to defeat the curse of dimensionality? This is our hope, kind of early work, but I will point you to Sean Gillen's PhD defense, which is, like I said, this coming Monday, March 14th. So look for announcements in the College of Engineering. And thanks for your time.
Thank you, Katie. Any questions?
Sorry for going a bit long.
Yeah, I have a question, quick question. So it's a bit, again, high level one, but you know, you are in robotics and using machine learning, and then you want robustness, but if we get the robot at home and then I have a child, it's going to fall on the child, and that's what I want to prevent. So do you think machine learning will ever get us there, that we can trust that we'll have robust machine learning that we can trust with safety around humans?
Yeah. I'm very skeptical. I feel like, my interests are mostly in things like, say, on Mars or something like that. Like working toward there. As soon as you have, especially when there's people in the loop. I mean, you just know as soon as the automatic driving cars go out there, there's going to be a bunch of 17-year-old people just lined up trying to destroy the system intentionally, right? So, I mean, there are a whole lot of reasons why this is a challenging thing long term. I guess my biggest hopes are somehow that we're going to come up with some tools that can allow us to put in some assumptions and get any sort of conservative estimates of robustness as a first start. And if you can do that, then okay, then we chip away at that. But it's a really good question. I mean, I don't even think we have like a monorail system that's fully autonomous, right? I mean, it's a really hard problem.
Thanks, Katie. Then now we have our last speaker, Nina Miolane, and she received her MS and from mathematics from École Polytechnique and Imperial College, and her PhD in computer science from INRIA in collaboration with Stanford. After her studies, Nina spent 2 years at Stanford University in statistics as a postdoctoral fellow, and then worked as a deep learning software engineer in Silicon Valley. At UCSB, Nina directs the BioShape Lab, whose goal is to explore the geometries of life. Her research investigates how the shapes of proteins, cells, and organs relate to their biological functions, how abnormal shape changes correlate with pathologies, and how these findings can help design new automatic diagnosis tools. Her team also co-developed the open source GeomStats library, a software that provides methods at the intersection of geometry and machine learning to compute with geometric data such as biological shape data. Thanks, Nina, for coming for this talk. Thank you.
Yeah, thank you very much for the introduction, and also thank you for the invitation. I'm very excited to be presenting our research today. So at the BioShape Lab, we develop innovative methods to do biomedical shape analysis with geometric learning. And when I say biomedical shapes, I mean shapes of biological structures such as proteins, cells, organs, and for example, the shapes of the brains that you see on the screen. And in order to analyze the shapes of these biological structures, we develop a new field of machine learning called geometric learning that is tailored to analyzing geometric data and, for example, shape data. So in this talk, I'm gonna show you why we think that there is biologically relevant and clinically relevant information in the shapes of biological structures, and also why we need a new field of machine learning to extract that information from these biological structures. But first, what is the overarching goal of this research? So the BioShape Lab performs biomedical research, and our main goal is to understand the fundamental mechanisms of life for the purpose of helping to enhance medical diagnosis and therapy. Now, who are the main actors of the mechanisms of life? They are the biological structures that I was telling you about. From the macroscopic scale to the nanoscopic scale, we have different types of biological structures. So we have organs, the brains, tissues, cells, organelles, and molecules down at the nanoscopic scale. And today in biomedical research, we are actually extremely lucky because in order to understand how these biological structures operate to realize the mechanisms of life, we can directly look at them. And this is because we have access to a wide range of imaging modalities from the macroscopic scale to the nanoscopic scale. So let me give you a few examples of imaging modalities. At the macroscopic scale, first, we have magnetic resonance imaging, and that allows us to observe organs. such as the human brain. But actually, all the way down to the nanoscopic scale, we have other imaging techniques that show us other biological structure. And all the way down to the nanoscopic scale, actually, we can observe very small biological structure, such as the human ribosome. Another point that I want to make with this presentation is that across these biological structures, across these scales, across these imaging modalities, there is one feature that is very interesting and that we are very interested in extracting. And this feature is the shape of the biological structures, or we could call them the shapes of you. And this is because there is a fundamental biological assumption that states that the shapes of biological structure are linked to the physiological functions of these structures. And instead of just stating that, let me give you an example of that fundamental assumption of biology. And for this example, I'm going to take Alzheimer's disease. So how is Alzheimer's disease related to the shapes of you? At the macroscopic scale first, Alzheimer's disease can be seen as a shape problem. So you can see on the screen a simulated brain of a subject with Alzheimer's disease, and you can see that the shape of this brain changes through time. The ventricles that are in the center are getting larger and larger, and this is because there is a corresponding atrophy of the brain matter around. Because there is this atrophy of brain matter, then the ventricles have more space and they extend. So I think it's pretty clear that at the macroscopic scale, for the case of Alzheimer's disease, there is a strong correlation between the shape of the brain and the progression of the disease. But even just staying with Alzheimer's disease, there is actually a shape problem at all scales, and in particular at the nanoscopic scale. And this is because Alzheimer's disease is called a double prion protein, which means that it's going to be a shape problem again. And this is because we have these two biomolecules called beta amyloid and tau that are going to change shape at the nanoscopic scale. And because they change shape, they aggregate inside the neurons or outside the neurons, forming these plaques and these aggregates, which in turn are going to lead to the death of the neurons. And the death of the neurons at the mesoscopic scale is also going to lead to shape changes in the shapes of these cells. So even by just taking one example of one disease, which is Alzheimer's disease, you can see that there are shape problems both at the macroscopic scale and at the nanoscopic scale. So we have established that shapes are linked to function, that healthy or pathological states of biological structures, proteins, cells, organs, lead to different shapes that we can extract from images and analyze from these images. And now our goal at the BioShape Lab is to inverse that model, is to extract the shapes from the images and turn them into biomedical discoveries. In order to do this, we follow a very simple pipeline, which starts with a biomedical question. For example, what is the signature of the shape changes in Alzheimer's disease? In order to answer that question, we acquire some images, and actually this part is mostly done by our collaborators, biologists and clinicians, both at UCSB and other institutions. And then our real work begins. We perform a step of shape reconstruction, which is extracting from the image which pixels actually form the shape of interest. We model this shape in the computer. I'm going to give a few details on this in a second. And when the shape is modeled in the computer, we perform statistics on these shapes to demonstrate a correlation. And now this shape statistics step is extremely important for biomedical research. This is because our downstream goal is to enhance medical therapy and medical diagnosis. And so when we provide new methods with this simple pipeline, we also have to be able to quantify the reliability of our tool or to quantify the uncertainty of our tool. And so we really need a technique that has some statistical guarantees in order to justify our approach, so that the shape statistics part. I'm going to give a few details on these 3 steps, and also convince you of why we need this new field of machine learning that I was talking about, this geometric learning subfield of machine learning. So how do we represent a shape in a computer? There are different ways. After the step of shape reconstruction, we have maybe segmented the shape of the brain, so we have extracted from the image which voxel correspond to the brain. Now, how do we turn that into a shape as an element, as a computational element, on which we can actually perform statistics with theoretical guarantees? So I'm going to introduce 3 main shape models. The first model of shape is to see a shape as a set of articulations, which is related to the talk that we had just before, inspired from robotics. So the spine, for example, can be seen as a series of vertebrae, and they're all related one from another with articulations. The moving body, or the dancing body, is also a set of articulation. Second example here, a molecule is a set of atoms that can move one with respect to the another, and you can also model that as a set of articulation. And here, when I say articulation, I mean a set of 3D rotation from one element of the articulated object to the next. So that's a first way in which we can represent, with which we can represent a shape in a computer. Second way. So once we have extracted this pixel that form the shape of the biological structure, we can put key points or features. So for example, we can put K points on K anatomical landmarks on an image. The first image that you have on the left is actually a glaucoma optical nerve. Here I put 3 key points that correspond to 3 anatomical features. Instead of just putting key points, you can extract the contour of the shape that you're interested in. So in the center, you have the contour of a cell, which is actually a cancer cell from a bone cancer. And we're going 1 dimension up. Instead of extracting the contour as a closed curve, you can extract a surface. So we've put features of interest on the original pixels that were constituting the shape. Now, in this second model, we don't define the shape directly, but we define the shape by characterizing what does not change the shape. So it's basically saying that the shape of one of these 3 examples, or the shape of my hand, is not going to change if I translate my hand, or if I rotate my hand, or if I rescale my hand. And so in this model, by characterizing what does not change the shape, we say that the shape is defined by all the properties of the object that are invariant by rotations and translations. So that's the second model of shape. And third model of shape, which is the one used in the brain example, is to see the shape as a deformation, a smooth deformation from a template. So in that illustration, the template is the brain that is circled in red. You take one image of brain, and you call that image the template. And now each of the other images from your data set is represented not by the image itself, but by a smooth deformation from the template to the image in your data set. And so that's the third model of shape, deformation from a template. Now, these 3 models have something in common. Whether we represent the shape as a set of articulation, a set of rotations, for example, or the properties that are invariant by rotation and translations, or as a deformation from a template, you can see that your data point, your shape data point, has a geometric nature. And what that means is that the shape data belongs to data spaces that have some geometric structures. So in the first example, in the first model of shape on the left, the shape is a set of articulation, a set of rotations. The data space is what we call a Lie group. In the second model, the shape is the properties that are invariant by rotation and translation. The shape data space is what we call a quotient space. And in the third example, the shape is a deformation from a template. And as deformations, the data space is also an infinite dimensional Lie group. So what does that mean for us in terms of machine learning? Actually, the fact that these data spaces are a bit exotic means that we need to generalize and redefine all statistics and all machine learning. So let me show you why. So we need to generalize computing, statistics, and deep learning to data on these exotic data spaces that we call manifolds. And this is because all statistics and machine learning has been defined for data points that live in a vector space. The vector space is, for example, this 2D linear plane that you can see on the left. That's the classical setting of statistics, machine learning, and deep learning. But now, the shape data that we see in all three models actually belong to what I call an exotic data space, which is a manifold, which is allowed to be curved, and actually is gonna be curved in most of the cases. So we are in the case that is in the middle. One shape, whichever model of shape you choose, is actually a point in this curved manifold. And instead of just showing you abstract spaces on the left, I've also put on the right the actual shape space of triangles in 2D. So you can see now I'm using the term geometry in two senses. There is the geometry of the data space and the geometry of the shape. On the right, you can see that the data space is the sphere, and each element of this data space is a shape, in that case, a triangle. And so we need to generalize statistics, machine learning, and deep learning to this type of data, which is something that we do in the lab, and that also we have made available to the community through this open source package called GMStats for geometric statistics, which is now reaching 80,000 downloads, and there is a big community starting to use it now. In terms of theoretical contribution, this is a whole program to generalize statistics to these exotic data spaces. I've summarized our theoretical contributions in this table, where the rows of this table characterize the geometric properties of the exotic spaces on which we want to generalize machine learning. So there are a lot of big words, but it's basically different geometric properties of the data spaces. So the geometry defines the rows, and the statistics and deep learning methods define the columns. So in statistical theory, you have a big subfield that is called point estimation that we seek to generalize to these exotic data spaces, but also dimension reduction, stochastic processes, and deep learning, of course. And with that, I thank you very much for your attention.
Thank you very much for the presentation. Any questions from the audience?
So for the open source repository that you mentioned, have you seen people apply this outside of the field of biomedicine?
Yes. And actually, I was thinking about that when you were giving your excellent talk. One of the first person who contacted me in 2018 was interested in using it for computational art. So I actually don't know what came out of it. I'm pretty sure he has a blog, so maybe we could look at it. But yeah, he was using this type of computations, specifically the hyperbolic geometry, to do computational art. So yeah, I think it's been used actually across domains, even though it was motivated by shape data. It's actually way wider than this. And I'm contacted by people in finance who want to use it, so I actually don't really know what they do with it. But I think it's one of the advantages of having a technological contribution, is that we put this out there, we want to use it for biomedical research, but we put it out there and we try to make it clean and available to users, and with that we hope that it's gonna have a life on its own and be useful for other applications. Yeah, architecture, yeah.
I think there's one more.
You mentioned earlier that So you mentioned earlier that different systems at different scales can influence each other. Could you envision geometric deep learning models? Do you think they have the capacity to learn from each other at different, for instance, if you have a model working at a small scale, could that influence learning at another scale? Is that something that you can envision with geometric deep learning is capable of?
So if I understand correctly the question, it's a great question. Is it, instead of taking one scale, macroscopic scale, and then one scale, nanoscopic scale, we have a model that goes across them in kind of a hierarchical fashion and design algorithm across these scales?
Something like that. I'm thinking of if a model at one scale can inform training at a model at another scale.
I mean, when I hear this question, I'm thinking about one of the biggest challenges in neuroscience, which is to reconcile these different scales. So in neuroscience, you have the nanoscopic view, and then the cell level view, and then statistical analysis, and then brain imaging, and then behavioral analysis on the very top. And there is kind of a division between all of these levels. Now, can one level predict another? I'm pretty sure there is a cascade of causal effect. I don't know what it is. Can geometric deep learning help uncover it? I think that will be a very good research project, actually, to see how one shape at one level combined on a multi-object approach can give some information of the shape at the other level. I haven't done it too much across scales, but I think it's one of the biggest challenges that we face with this research.
Thank you.
Hi, great presentation and super interesting work. I have a maybe slightly naive question. So clearly you can represent the manifold and the geometries, discretize it and represent it as vectors, right? So what are the main benefits in doing the machine learning directly on the representations that you suggest over a vector discretization, given that we have probably more knowledge right now in what the machine learning architectures do with vectors. Yes. And so there's probably catch-up to do on the learning on your new representations, right?
Yes, so that's a great question. And maybe I can give a first answer by making a transition with what Katie said at the end of her talk, is that sometimes the data live in a very high-dimensional vector space. And if we do the learning in this high-dimensional vector space directly, we're going to have less power, less statistical power in making predictions, compared to if we know that they're restricted to some lower dimensional manifold, we can restrict the learning there. And so in practice, it means that we incorporate prior information that helps increase our statistical power. So that's one. The second one is kind of a hope. I don't think we're there yet, but by reducing the dimension, going from high dimensional to a lower dimensional but curved space, usually if you do computations that are lower dimensionals, you're going to be faster. I say usually because we're not there yet in the sense that it's still a process to do the computation directly in the lower dimensional curved space. And so depending on the cases, sometimes we're faster, sometimes we're not. But on that point, I've been contacted by a lab that designed new transmitters, so new hardware component, and they are specifically interested in speeding up this process on the hardware side. So I think if we can overcome that challenge, which is that we're not that much faster, even though we're lower dimensional, then it's going to be a big push. And I think the last argument maybe is that it's more intuitive to perform the computations there. So we have the data space of the shapes of triangles on the right, so it's the sphere. But imagine this sphere represents the Earth. And if for some reason you want to do statistics on the coordinates of the cities on the Earth. Now, one city, you can represent it as X, Y, Z, coordinate in 3D. But it's going to give you less information compared to if you're represented by longitude and latitude. So by working in the lower dimensional subspace, you're actually working with the principal dimensions of the data, which makes your results down the line more interpretable.
One last question. After that, we have actually, we got a copy and cookies, so we can continue discussion. But last question. Yes.
Oh, thank you. So at the beginning, you had said an obvious thing is there's an application for this, like the diagnosis of whatever. And so I didn't see how accurate do you feel? I mean, and are you really in the mission to have this be used as a diagnostic or like a, evaluation tool? Because, obviously the most important thing is the accuracy, and how far are you along there?
So that's a great question. Let's see. So the whole idea of generalizing statistics is that we can quantify this accuracy in terms of saying what is the uncertainty associated to the computation or of that shape. To give you an example on brain template computation. Okay, I thought that was clear. All right, this one. So a lot of my work in 2017 was about quantifying the uncertainty associated with the computation of the template that you see on the left of the third model. So all of this, of the diagnosis pipeline, a lot of diagnosis pipeline in brain imaging work the same way, in the sense that you take the brain of a new patient and you compare it to, so compare it by computing a deformation, to a template, which is actually the template that represents the mean healthy brain. So you take hopefully big amount of brain images, MRIs from a healthy patient, you compute the mean, and then you compute the deformation from the image of the new patient to that mean. Now, the problem was that before the research I did in 2017, people hadn't evaluated accurately what was the uncertainty associated with the computation of the template. And so if the template, which is everything on which you're basing your analysis, is actually biased itself, and it was biased in the sense that it was showing anatomical structure that were actually only due to noise, then the whole pipeline down the line was actually biased too. And so there were some uncertainty associated to the computation, to the automatic diagnosis of this or that disease, but actually these computations were wrong just because at the very beginning of the pipeline, the template itself was biased. So I don't remember exactly what was the, so 2017, but what was the accuracy that was made in the prediction of this or that disease and how much we improved that. But it's basically given another reason why we need a statistical theory to be able to quantify these uncertainties.
Well, thank you very much, Nina.
Thank you. Thank you.